Good morning, ladies and gentlemen, and welcome to day 2 of the Water Security Driven by IR 4.0 Virtual Symposium. Today we'll be discussing municipal freshwater environment and water resources governance. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the Water Security playlist. You can go there and check out a recording of day 1. In the chat function box, in the chat box, you will find a link to subscribe to the SAIEE TV channel. Please click on it and register, it's free. A certificate of attendance will be issued a few weeks after this webinar once we have received the CPD validation number from EXA. I'd like to introduce you now to our host. Firstly, Dr. George Sibani, who is a senior researcher at University of Johannesburg. Dr. George has more than 30 years of experience in capacity building, training and development, complemented by program evaluation and research in public policy and management. He has worked in these areas with various sectoral departments, state-owned enterprises, development finance institutions, and international development agencies. Dr. Tabani's co-host, Ms. Zibuzethu Matendra, who is the chairperson of Umgeni Water. She was appointed as a board member of Umgeni Water in May 2019 and is currently the chairperson. She is also the chairperson of the governance committee and a member of the ethics committee at Umgeni Water. Over to my hosts. Thank you.
Good morning, colleagues.
Good morning, colleagues. Good afternoon, those that are experiencing an afternoon. And maybe we can say good evening, those who are experiencing a good evening. Dr. Nsibane, if you can kindly take us through the agenda for today.
Good morning, colleagues, and good afternoon to those that are outside the country. You are welcome to this seminar. My name is Dr. George Sibani. I'm co-hosting it with Mrs. Zibuzethu Matendra, the chairperson of Umgeni Water. The keynote address will be done by the Department of Water and Sanitation, Dr. Benson Mwaka, who is a director for Water Resource Management and Planning at the National Office. This will be followed by Dr. Mandla Msibi, well known in the water sector as in terms of the Water Research Commission. We'll also have an early warning presentation by Mrs. P. Mudirai and Mrs. Kotan. We'll also have a green engineering model which will be looking at water pool by Kwalisile Kunene and Mrs. Tobekile Gambu. And we then have how the 4IR is linking to the gaps in terms of skills and future skills by Mrs. Mpo, the CE of Energy, Water Sector Education and Training Authority, Mrs. M. Mokopane. And then we'll have a presentation based on practice and experience by Mr. Kevin Mayer from Umgeni Water on non-revenue water, because that's a very critical issue in South Africa and African continents. And then we'll have a Q&A session. Then we'll have a summary of the proceedings of the day by Mrs. Sele and Mrs. S. Rico from EWCTA. And then the way forward will be done by our host, Professor Pat Naidu, a visiting scholar, a host and a coordinator, a person that originated this symposium, and then we'll have a vote of thanks.
Thank you so much,
yeah.
Ladies and gentlemen. Let me take over to Doc. Maybe we can proceed before I look at the purpose of the session today.
Yes, I'm going to hand over to you, Chair, to do the purpose of the day. Thank you.
Sorry,
Thank
Dr. Sabani. Sorry, Ms. Muthenjwa. Dr. Sabani, we're waiting for you to share your screen with us.
Yeah.
Just swap your display settings, please. In the center, at the top. Yeah, click there. Top one. Swap presenter view slideshow. There we go. Thank you. Please proceed. Just move your control panel off the screen.
Yeah.
Thank you.
Thank you so much, team. I think this is an indication that I can proceed with the presentation. Doc, is that an indication that I can proceed with the presentation? Now,
Please.
the purpose, knowing that today is going to be very exciting, we heard from Dr. Nsibane on what the presenters will be covering. So I don't want to stand between the exciting presentations and yourself. But maybe just briefly to look at the purpose for today, and is to look at the following. Maybe I would look at 3 or 4 of them, so that then I can wait for the other speakers to look at other items in the purpose for today. Now, the first and maybe the important one is the current environmental problems, and check if they can be checked to industrialization. We've seen quite a few problems in terms of our water, in terms of our environment, in terms of our sanitation. And the purpose for today is how can we use 4IR to check what is the cause of these problems. Now, the other purpose of today is to see how the move from 4IR to 5IR is affecting our space in terms of water, sanitation, and the environment. We have seen that this move is happening very fast. This move is talking to efficiencies, and we want to see how this move will ensure that everything is more accessible than it was before. The purpose for today as well is to look at all these, I would say, new words that are coming with new technologies. We've got the Internet of Things. Now, 20 years ago, 30 years ago, this wasn't a big thing, but for now, what else can we benefit from the Internet of Things? We have virtual reality. We've been reading recently, everybody is doing a virtual reality of something. How does it help? Now you can look at areas of training, you can look at areas of education. There are quite a few areas you can look at. How can us as the water sector benefit from virtual reality? Now, the schools that we have, it could be academies, could be schools of education that are meant to highlight areas in the water sector. How is the impact of the virtual reality? We also have artificial intelligence. Now, how far are we? Have we started? Haven't we started? If we haven't, how far are we from starting? And to move into the questions maybe we look at today is these new technologies, are they maybe enhancing or exacerbating the threats to environmental security, or do we have new threats? Now, in some of the presentations, I would like the speakers maybe to look at, is this an existing threat that is now becoming bigger, or this is an entirely new threat that we can look into? So how do we then use 4IR and 5IR to look at those threats? Now, if we look at this as a transformation, because this is transformation. I mean, when we started this session, we had to show Dr. Nsibane where to press. 10 years ago, there was no requirement. We had a flip chart and everybody was good. Now, each time you want to present, it's like click this, click that. So this means that we need to do this together. We need to do it together as the sector I would say, environmental sector. I would say a sector maybe in the water sector. I would say the sector maybe in sanitation, because sometimes when you say environmental, some people are saying where is the water, where is the sanitation? But it says no one can do it alone. So us as stakeholders, we need to collaborate and ensure that we then enhance our services through collaboration. So I'll end it there. And to me, I'm looking forward to the day. Doc, I'll hand over to yourself as we move with the next speaker. But for me, the purpose of today is how far are we? Where are we? Let's go out and grab the fourth and even the fifth industrial revolution. Thank you so much, ladies and gentlemen.
Yeah, kick out. Colleagues, can you hear us?
Yes, loud and clear.
Kick us out.
Hello?
Yeah, Dr.
Yes.
We can hear you loud and clear. Where we are in the program now, we're introducing our next speaker, and we have the profile with us right there, Dr. Mandla Msibi, known as Mandla Nkosi Msibi. That's I'm sure the rest of the colleagues can see the question. Maybe Mr. Msibi and I are able to see the profile of Dr. Msibi.
Colleagues, we apologize. We just have a load shedding and we are back now. Is it possible for Mama Tendra to continue introducing the guest speakers?
Yes, we are presenting to you Dr. Mandla Nkosi Msibi. Mandla Nkosi Msibi is a Group Executive, Innovation and Impact in the Water Research Commission. And I'm very excited, as I say, innovation and impact, because this is the purpose of today. Dr. Mandla Msibi is an environmental, what they would call a pollution scientist. He has a PhD in environmental chemistry from the University of Birmingham in the United Kingdom, and an MBA from the University of Pretoria. Dr. Mandla has over 20 years experience as a researcher, research manager, knowledge manager, and innovation and technology transfer executive. He has worked in the water sector and in the academic research environment. In the last two institutions where Mandla worked recently, he achieved remarkable results and raised the bar for the institutions. Dr. Mandla Msibi, if you can come through, we are excited to have you on board. And if you can maybe try and share your presentation with us, and we'll be very excited to hear from you. I know whilst Dr. Msibi is still loading his presentation, he has done quite a few things in terms of the water sector itself. I have seen some of his work, and it's quite exciting. Dr. Mandla Msibi, if you can come through, the floor is yours. Thank you.
Good morning, colleagues. I hope you can hear me, and I also hope you can see my presentation on the screen. If I could receive a confirmation.
Dr. Msibi, if you can please just click on your display settings in the top, at the top of your screen, and
Display
then
settings.
the first one. Yes, click on that. Perfect. Thank you. Please
You
proceed.
can see everything.
Please, you just, yeah. Sorry, sir. Can you please just remove your control panel off the presentation? There we go. Thank you. Please proceed.
You sure you can see my presentation or my picture?
Sir, you can actually make your picture smaller, then you can see your presentation. It won't affect us. We see your video on top of your presentation.
Okay, let me try. All right, is that okay?
Perfect. Thank you.
Perfect. Colleagues, thank you so much, and I really appreciate the introduction. It's very humbling. I didn't write it myself. One of my colleagues, I guess, wrote it. I'm going to talk about the water market pool as a disruptive model for SADC, for SADC. And this presentation is based on a desktop study that was carried out by the University of Johannesburg and funded by the Water Research Commission. What I'm gonna do in this presentation, because we have a range of people coming from a range of background, I'll try to simplify and give the introduction to the market pool. And at the end of my presentation, I have a link to the actual report that was generated from the study. And that report is available on the WRC website. Okay, I'm trying to advance my slide. Okay. So to introduce this particular topic, we are all aware in South Africa that a few years ago, there was an introduction of a new service called Uber. And when that service came, it really disrupted the taxi industry, such an extent that there were some protests, and also it went to the extent of some violent behavior. What had happened is that for the customer, instead of dialing each taxi service to find an available taxi, you have only one contact center, and that will connect you to the taxi that is readily available, or to the transport that is readily available for you. And behind that service is a platform that connects drivers and guests via the internet. This is an example of how industries can actually introduce or bring about a disruptive business model. That's actually a very good example. Now, what is a disruptive model? Disruptive model is when a new business or a new business model is developed and is introduced into an existing industry or an existing product or a service. And then that business model will actually change the way the business is done. The powerfulness of that disruptive business model is in that it focuses on the customer. So it is able to meet or capture a particular demand, an unmet demand, because it will appeal to the customer. So it's addressing a gap. The word gap has actually been used here. In every market, you'll find that there's a gap, and most of the time it's around the customer. Now, I also want to touch on the marketplace, especially the digital marketplace. So what you have behind the Uber service, for example, is the digital platform that does the connecting the seller and the buyer. What is actually happening is then that Uber does not drive the cars and does not own the cars, but it's generating money. And you can call this money brokerage fee, you can call it commission or transaction cost. That is the important part that we'll look at today, that with the advent of 4IR and the associated technologies, we are in a position now to create new business model that will disrupt the way we've always done business. And these business models will be such that there are people who own, there are people who operate, there are people who maintain, and then there are people who are running those platforms, and everyone in that sphere is benefiting one way or another. Other examples that I can put forward is Netflix. Netflix does the same thing. People generate content. Netflix has created a platform that connects the content to the viewers. I still have Uber there, eBay. But one other practical one that we have at our doorstep is a Johannesburg fresh produce market. So in order to study this concept and understand how it may benefit the water sector, these two business models were looked at. So now, there are two things that are critical on these business models that we were looking at. Number one, they were addressing a repressed demand, a demand that was not being met. If you look at the Johannesburg fresh produce market, you have got farmers spread all over the country, or at least all over the province, and you have got demand, people who want to buy, or consumers of those vegetables also spread. How do you connect the producers to the consumers? That's where the Johannesburg fresh produce market comes in. Then the second part deals with the quality of the product and other associated issues. I will touch on that as I continue with the presentation. So these two considerations are very important. Now, this particular project, therefore, by the UJ project team, which was led by Prof. Pat Naidu, the study was actually completed in March 2021. It was titled Water Security Driven by Industrial Revolution 4.0. And the theme of the study was towards developing a technology-driven water pool model for bilateral and competitive trading water resources. It's very important that the word competitive trading becomes, we take note of, because you will see that in the two examples that we studied, the whole operation was very beneficial, profitable, if I can use that word. So in their approach, or in the approach of the study, we want to see how, in a similar way, we can handle water resources, which are also spread all over the country, all over the province, all over the region. So when I talk about region, I'm talking about SADC. So we've got water resources spread all over, and we've got people spread all over. Now, the thing about water resources is that at any given moment, they are not spread uniformly. In some places, there's a drought. In some places, there's a flood. In some places, they've just never had enough water. In some places, they've always had enough water. But also the water users are spread all over our region, SADC, and we need to connect them. We need to connect them to the water. So hence the model that was developed by. So what was also considered in that project is that how do we bring together big data, markets, and cash flows? So in other words, in as much as we need to deliver on the service, we need to look at a model that will deliver financial liquidity for all, because otherwise there's no incentive for participation, and then whatever we try to do will collapse. And that's a very important consideration. So we have a market of traders, we have got brokers, we have buyers, we have sellers, and then above all, and I note, in fact, I think even as we speak, the thought is knocking in our minds, what about the infrastructure requirement to pull this thing off? Now, I've already mentioned the two case studies, the Southern African Power Pool model and the Johannesburg fresh produce market. What the study focused on was what lessons can be drawn from these studies to inform our thinking on the water market pool model for SADC. Now, if we look at the Johannesburg fresh produce market, farmers and producers of fresh products bring their produce into the market and the buyers come. There are systems, there are processes, there are procedures that enable the consumers to purchase and pay for these vegetables in this central place. The South African power pool model as well works in a similar way. Electricity is being produced by various producers spread around SADC. Sometimes you may have excess electricity with the usage down in this particular area, whilst in another area, there's a huge demand, but there isn't much coming from the producers. So if you create a platform where if you have got excess electricity, you sell it to a pool. And if you have got a more demand than supply, you purchase from the pool. You're creating an environment where there's sustainability and assurance of supply. But important amongst those things is that the players, the producers, and the consumers, and the managers, if I can use that word, of the model itself, the providers of the tool, they are all benefiting. That is the beauty of this particular approach. So what lessons can we learn? Now, one of the things that you will see about this business is that it is a self-regulating business market model. So it does promote, and that's a very important thing, this competitive and bilateral trading of a service between buyers and sellers. But also, which is very critical, and that's a question I said might be knocking in our minds as I'm speaking. What about the infrastructure? It has the ability of supporting investment into the development of engineering infrastructure. Even in the case of water, it will be possible that the money generated actually encourages investment in the infrastructure to deliver the physical water between buyers and sellers. So what does that trade, how does that work out? One of our limiting ways we think is that there is water, there is wastewater. One of the critical things to make this model work is that there's nothing like wastewater. All water is water. And all water can be traded. And at the point where the water is received, the quality can then be controlled at that point. And that becomes important because questions can be raised. How do you then allow the transfer of certain chemical elements from one point to another? Won't that disrupt our environment, and what will it do? But if we look at water as water, whether we're talking about virtual water, bulk fresh water, bulk fresh natural water, bulk ocean water, technology cleaned and purified used water, bulk industrial, mining and commercial wastewater, bulk municipal sanitation water, rainfall harvested and ground stored water. All that we look at as water, and it can be traded. Now I know that lots of questions may also come. How do you trade wastewater? Yes, we should be able, with our technology, to trade wastewater. The question on infrastructure. The wheeling and delivery infrastructure and systems will be engineered, commissioned, operated, and managed for both bulk transfers and last-minute service delivery of forward fresh and return waste and used supplies. Now, I'm reading this statement because it's very important that there has to be infrastructure that is appropriate for the services. In other words, you think of SADC. Therefore, it means there has to be infrastructure connecting the whole region in one way or another. But can we see a way forward in terms of how this infrastructure may be financed or funded? From what we have learned from those two models, the answer is yes. That development of the infrastructure can be funded. The trading activities will result with profits. And those profits are also for the benefit or shared amongst the infrastructure investors, if I can use that word. Now, in summary, Let me look at the Johannesburg Fresh Market in just some points to reflect on. It was established in 1873. This market doesn't own any food, doesn't have any farm, does not produce the vegetables or the fruit. It has got nothing that it's actually marketing for its own. And even the delivery infrastructure to bring in the vegetables and the fruits into the market and to take them away, it doesn't own. But it acts as a coordination office, as a broker, if I can use that word. But what has happened is that it has an annual turnover of about 10 billion. And then realizing a commission of about $500 million each year, or approaching $500 million. Now, when you look at that, you can see that there's a lot of activity that is happening there. There's a lot of sales, there's a lot of buying, there's a lot of transactions. What that means is that those who are owning the food, the farms, the produce, and those who are buying and those who are delivering, providing the trucks and so on and so forth, are actually seeing benefit in all that. And that is actually working. Let me look at the next one very briefly again, the Southern African Power Pool, founded about 3 decades ago. And it owns no electricity, no power stations, no power lines, no infrastructure to distribute the power. Basically only offices and the tools to actually manage and coordinate the transactions. It connects buyers and sellers of electricity. It allows the purchases to be supplied to the buyer. And today, this Southern African Power Tool is a multi-million US dollar liquid market. It's profitable. The fact that there are transactions happening means that there's a benefit for all involved, for those who are transmitting the power, those who are buying, and those who are selling. The question, therefore, is, can we take something from that? Does that mean anything for the water pool model? Can it be done to trade and transact water as in the other models? I've already mentioned the fact that we've got unevenly distributed freshwater sources. On top of that, there are variation in seasonal precipitation, there are droughts, there are floods. So we need to be sharing our water resources so that we have a sustainable region, that is SADC. What will this model do for water, therefore? Amongst other things, it will smooth out the balances in supply and demand. In other words, while even when you look at South Africa, while other parts of the country have got excess water, other parts could be struggling for water. It also strengthens and enhances resilience in dynamic and changing environments. We are aware that our climate and our weather conditions are becoming a big challenge year after year. So to be in a position to deal with such occurrences, especially if they affect one part of SADC, if we've got the infrastructure and we've got this model working, you will see that we are in a better position to deal with such challenges. So what can we do in this region? And what can we do as the people tasked with providing water services? We'll start, first of all, to be able to put value to water, to make sure that we understand the value of water so that we can transact. That is one of the first things. Then when we do that, those who need to invest in the infrastructure will begin to see that investing in water infrastructure can bring back very good returns. With that said, I just want to highlight the fact that the report that I'm summing up here, I'm summarizing, is available on the WC website, and the link is the one that is shown on this last slide. With that said, colleagues. Thank you.
Thank you so much to Dr. Msibi. It's highly appreciated. And we do have our next speaker, and taking away from Dr. Msibi, most importantly, I just want to read something that he said before I give to Ms. Kolam. And Dr. Msibi's words, he says, it talks about a water market pool that will promote and manage competitive and bilateral trading of water between buyers and sellers. So for me, in summary, and that's what I've taken from him, and it made me to start thinking about water skills. When I look at this model, the Uber of water, I then started thinking, okay, this talks to a pool that is more than infrastructure pool. It talks to many other things that can happen in water. Now we still have a Q&A session and a discussion session. I would like to kindly introduce yourself, Ms. Kolam, who's a process engineer for Umgeni Water. She holds a master's degree in chemical engineering and is a registered professional engineer. If you can go back, ma'am, for me. Yes, and she's a professional registered engineer with EXA, which we all believe is quite a good move. She started a career as an environmental consultant and joined Umgeni Water in 2008 as a process engineer. She developed and maintained the guidelines used by Umgeni Water for undertaking process audits of water and wastewater treatment plants, and works with interdisciplinary teams to ensure that water quality compliance is adhered to. She has also undertaken research projects funded by the Water Research Commission and contributed to the training of chemical engineering graduates. Thank you so much, Ms. Kolam. And I believe it is the two of you in the presentation. May I also maybe do the next introduction, so that then as they continue as a duo. Now, I would like to introduce Ms. Madurey, who's also a process engineer for Umgeni Water. And she's a professionally registered chemical engineer with over 10 years of experience in the water and wastewater industry. She is working at Umgeni Water as a process engineer and studying for her master's degree. She has been published in the Water Research Commission project and has presented at a national conference on various topics in this field. Ladies and gentlemen, I'm presenting the two ladies to you, and now I would expect them to connect their presentation and they can share their lively presentation. We were looking forward to it. Thank you so much. Ladies, the platform is yours. Then you'll be guided on how to share your presentation. Thank you.
Thank you, Ms. Matendra. Good day, ladies and gentlemen. My name is Prasanta Madure, and today I will be presenting with my colleague, Sachita Kolam, on the topic water adaptive capacity and the need for early warning systems. We have learned much about water security thus far, and it is clearly not a single issue, single solution problem. There are many factors that are linked to water security and ensuring a sustainable, resilient future. The focus for our presentation today is on drinking water quality, which links to the Sustainable Development Goal 6 for clean water and sanitation. What does it mean to adapt? To paraphrase Darwin, we must adapt or die. How well can our water systems cope with changes and uncertainties in climate change? Do we have the ability to reduce vulnerabilities and be proactive to minimize the consequences of change? There are many ways for us in the water sector to enhance this capacity, as shown. Today's presentation and the symposium reflects the learning aspect of adaptation, which refers to improving our capability of processing new information and adjusting our responses accordingly. It's the generation and sharing of knowledge. Flexibility represents how well the different sectors are able to change their responses and have alternate actions in place. Assets refer to the resources needed to respond to change. These can be technical resources, financial, services, etc. The more resources that are available, the better the capacity to adapt. Organization in this context is not a business or a company, but refers to the relationships between people, communities, government, etc., that work together to provide a robust capacity to adapt to natural disasters. Agency points to people's belief in their own responses. In this case, their response to climate change. A country cannot change unless the people have the will to do so. In the drinking water production process, the inputs to the process can be considered to be the raw water. Both the quality and the quantity of raw water are important considerations. Processing refers to everything required to convert the raw water into the final product. This would include the unit treatment processes, chemicals, utilities such as electricity and telecommunication networks, and human resources, which encompasses skills, procedures, and automation. The output of the process is drinking water, which must meet the national standards in terms of quality. The required quality of drinking water is critical for water security, in addition to meeting water demand. The scope of today's presentation, however, excludes water quantity due to time constraints. First, we will discuss the inputs. Extreme climate events, such as flooding or drought, result in deteriorating source water quality. This is exacerbated by pollution of water sources, by industry, sand mining, agriculture, or discharge of untreated sewage. These factors introduce major challenges to the treatment process in achieving the potable quality standards. The ability to meet the consumer demand is also negatively affected, highlighting the necessity for our systems to adapt. For example, during the Easter floods in KZN, a water treatment plant, which normally has a raw water turbidity less than 20 NTU, experienced a sudden increase to around 450 NTU. This required a rapid response and tested the plant's adaptive capabilities. One of the major impacts during a flood event is the damage of conveyance infrastructure, resulting in a reduced quantity of raw water supplied to treatment plants, or no supply at all. Access to raw water sources can also be affected, which limits the ability of operations to acquire samples or adjust abstraction levels as needed. It is critical for systems to have redundancy in infrastructure, and having interlinked systems, either between sources or treatment plants, will allow for this flexibility. An example is the construction of Inanda Dam after the 1987 floods in KZN, as well as the action of installing raw water pipelines underground to protect against flood damage. These interventions greatly assisted in security of water supply during the recent KZN floods. Transboundary connections, nationally or between SADC countries, should also be evaluated for further opportunities. Alternate raw water sources such as desalination, groundwater, and possibly storage of excess water during flood events for later use should be considered. The automation of abstraction valves and treatment plants is critical when access to sites are limited. Drone technology could be utilized for sample collections or other emergency supply deliveries. Early warning systems play a vital role to assist in forecasting disaster events to allow for a timely response. Climate change in Southern Africa is predicted to result in frequent extreme weather conditions in the future. The implementation of detailed and accurate weather forecasting systems must be prioritized. Modeling is currently being done at Mgeni Water, utilizing the Antecedent Precipitation Index, the API, data from the South African Weather Services, as well as our own flow monitoring sensors and devices for early warning systems. However, there are limitations in the data for predictions, particularly comparing drought to flooding events. The system, however, can only be effective with timely and good communication between all stakeholders to implement the corresponding correct actions. It is a movement towards implementing 4IR technology with big data management, Internet of Things, digitalization, and AI. I will now hand over to my colleague, Sachita Kolam, to take us through the process.
Hey everyone. Apologies for the delay with the slides coming up. Our network is a bit slow. So let's move on to processing. As Prasanta has mentioned, marked changes in the raw water quality matrix occurs during floods and drought, and this poses many challenges to the treatability of the raw water. Historically, plants have not been designed to take into account the impact of climate change. Typically, quality monitoring of the water source would have been undertaken for a few years prior to the design of a treatment plant commencing. Plants are then designed to treat the 95th percentile of each water quality parameter. As a result of this, for example, dosing systems have not been sized for the high chemical dosages, which may need to be applied during floods. Upgrade of dosing systems and other processes, now especially after the lessons learned in the April 2022 floods in KZN, is necessary. In terms of flexibility, it's necessary to have readily available dosing systems to respond to, for example, drops in pH during floods or taste and odor issues due to eutrophication of the raw water sources during drought and so on. Principles from the just-in-time concept would assist in reducing setup time when there's a sudden need to dose chemicals which are not used during normal operation. Changes in the raw water quality may also warrant a change in the type of chemicals being dosed, as was the case in the April 2022 floods. However, procurement challenges was a bottleneck which caused delay. Going forward, an enabling legal framework with more flexibility in procurement under emergency situations would need to be looked into. Also, having interlinkages between unit processes can improve responsiveness when normal plant operation is altered. For example, having the flexibility to use your clarified water as carrier water in the chlorine dosing system or for more frequent cleaning of filters is useful to have when reservoir levels are low due to high demand. Such pipework can be retrofitted at existing treatment plants. Now, while we may have the required assets available, but if these are not properly maintained and kept in working order, then there's little purpose in having these in place. It's often found that infrastructure which may not seem that critical during normal operation, like that stirrer on a flocculation tank or an online instrument that needs repair, but is not being prioritized since the plant is coping without it. These become great barriers when hit by a crisis. So improved management of the planned maintenance schedule and asset management action plans are necessary. Aging infrastructure is a frequently cited challenge in recent years, and it's imperative that financial investments are made to replace infrastructure which is reaching the end of its life. Now, standard operating procedures at treatment plants have generally lacked the actions that need to be taken to operate unit processes during sudden deterioration in raw water quality. During the April 2022 floods, this left operating personnel and engineers having to reactively act in terms of monitoring and optimization. So going forward, SOPs at treatment plants need to be updated and staff need to be trained to enable a more planned response to water quality challenges. The development of various types of decision support systems would also assist. Manually optimizing treatment processes is challenging in times of crisis, when monitoring and control of the entire treatment chain is very critical. So automating processes, incorporating artificial intelligence to reduce the overwhelming workload on operating personnel is necessary. A simple example of this, optimization of the sludge removal rate in clarifiers due to the high incoming solids load is something that can be very easily automated, or even adjustment of the mixing intensity in a flocculation process is another example. Now, having great early warning systems is wonderful, but failing to have these trigger response plans where everyone is aware of their roles and responsibilities, it's a shortfall in improving the adaptive capacity of water. Risk assessments, which likely didn't adequately consider catastrophic events, would need to take that into account so that gaps in response plans, infrastructure, communication protocols, and so on can be addressed. Within the organization, plans for flexible reallocation of resources to where needed need to be made. For example, during any crisis, climate-related, COVID, or any other type of crisis, operating staff who are not able to come to work need to be promptly replaced. So having readily available backup staff and even ensuring that engineers and scientists are trained and can temporarily man the plant is essential. Also, plans to access the site, for example, when access roads are washed away during floods, need to be made in advance. And this includes contracts and agreements for priority reservation of helicopters and other tools which are needed for this purpose. Water supply cannot be achieved without considering the energy supply. So having backup systems like UPS and generators are essential to keep the treatment processes online. It probably goes without saying, but ensuring that there's sufficient fuel for the generators should also be on the checklist. Renewable energy options are attractive, and where necessary, funding for this needs to be looked into to make these options more affordable. And there's much dependence on cellular networks for communication purposes. But what happens if your cell phone tower is washed away during a flood? So it's useful to have some sort of a backup system in place. Back in 1987 floods, we had two-way radio communication. Investment in other innovative ideas for mitigating against loss of communication, like satellite technology, is essential to be looked into. Moving on to output. In terms of drinking water quality, SANS 241 is the compulsory standard adopted in South Africa. It details, among other things, the limits for the various drinking water quality parameters. Much resources are required to ensure that the water quality meets the SANS standard, both in terms of the treatment process as well as the monitoring requirements which are stipulated in the standard. This water, which is treated to drinking water quality standards, is currently being used for various other purposes other than human consumption. Apart from this, with more than a third of the treated water in South Africa being unaccounted for, this puts unnecessary strain on treatment facilities to meet the demand for water to be treated to drinking water quality standards. South Africa ranks among the 30 driest countries in the world and is extremely vulnerable to the impacts of climate change and needs to be engaged in interdisciplinary collaborations with various water users to come up with solutions for improved water use efficiencies. Use of options like rainwater harvesting, groundwater, and reused water for purposes which do not require water to be fit for drinking are avenues which need to be explored and which will translate into less costs associated with the production of water which meets drinking water quality standards. These are some of the references we've used in our presentation today. That brings us to the end. Thank you very much.
Thank you so much, ladies. The presentations are beautiful. And then maybe whilst we're waiting for information on the next speaker, what I've learned from the presentation is that your understanding of the technologies that we have is best maybe reflected in the way you've broken it down. The first presenter was looking at outputs, so in inputs, to say when we look at technologies, we must then break it down into inputs. We must also look at processing and also look at outputs. And now in the inputs, we might have seen some of even our recent events where there was information on flooding and how it disrupts our system and other examples. Now looking at processing, there's a lot of information that was shared, especially the importance of JIT and the automation of operations. One thing also that was touched upon will be your renewable energy, and maybe the telecoms backup is quite a big issue. What do we do? Do we go for the satellite? Do we go to the metaverse? What is the next new thing? It got me thinking. And then on outputs as well, the importance of us complying with SANS 241, and maybe one sentence that says drinking water versus other water. I think it's very deep because there's so many other classifications of the kind of water that we have, and how can we use technologies to ensure that then we manage the different types of water differently. So that was very exciting to learn about the input, processing and output, a very good summary of the key process in our water management and our water production. Thank you so much, ladies and gentlemen. I would like to introduce you to our next speaker. Her name is Thobekile Gambo. She is an environmental scientist in Umgeni Water. Ms. Thobekile Gambo is an environmental scientist, a professionally registered scientist, and an accredited green building professional for the new buildings. Thobekile has a master's degree in environmental management and a master's of science in chemistry, and is currently pursuing a PhD in engineering at the University of KwaZulu-Natal. Thobekile has over 10 years of work experience in environmental management and water quality management. Thobekile, please connect your presentation and the floor is yours. Oh, I have also, sorry, the slide came a bit later. I have Kwali as well. Kwali Silebunene is a professional civil engineer in Umgeni Water. And if you look at her profile, and she is a, okay, these are two lovely ladies. They're coming on screen at the same time. And the name that we have for now, on the left-hand side, you'll see Thobekile Gambo. And then on our right-hand side, you see Kwalisile Bunene. For those that are from a distance, then they can separate the two ladies. Kwalisile Bunene is a professional registered civil engineer with EXA. She has 14 years of bulk civil infrastructure design, construction management, and engineering management experience. She has designed and constructed water infrastructure worth billions of rands in her career. She holds a postgraduate diploma in management from UKZN, which is University of KwaZulu-Natal, and a certificate course in arbitration from the Association of Arbitrators in South Africa. Thank you so much, ladies. I'll give it to yourself. Just a reminder to the team, Thobekile is on screen. She is on the left-hand side, and Kwalisile, in terms of the screen, is on the right-hand side. Thank you so much, ladies. The floor is yours. Thank you.
Thank you so much. I am going to hide Kwali for now. I'm hoping that you can see my screen because I can just see myself. If I can get assistance with separating the two.
Ms. Gambo, you can just minimize your video, your webcam. We can still see you, and then you can see your slides. Click on your webcam
so
and you can
okay, thank you.
we can see your slides. Thank you. Please proceed.
Good morning. Thank you so much to our session facilitators. Thank you, Chair. My name is Thobekile Gambo, as already mentioned, and I will present alongside Kwalisile. And ours today is to present green engineering solutions for the water sector in the SADC region. So the reason why we're here is basically to bring some insights and aspects in that regard. Our presentation will follow this outline, which is touching on climate change impacts on natural resources. And if we do not speak about this, then we're not aware of some of the problems that we actually faced with. If we want to implement this water market pool model, we need to know what issues we're faced with. We'll speak a bit on the water scarcity in the SADC region. We'll touch on the water energy food nexus and how these are interdependent on each other and how important it is to actually find the balance between the three. We'll then touch on the green engineering solutions because that speak directly as well to some of the issues that we need to put our efforts towards, specifically speaking on climate change. We'll then zoom into one solution, which is ecological infrastructure investment. And this is really, this was an opportunity for us to showcase this and speak about it on this platform, because it is one which is less spoken about, but very important. We'll then touch on the water trade or water trading in the water market pool model and just in the water market, because we feel that this is definitely something that can be a building block towards the larger envisioned water market pool model. So before we go before we go into the details, I'd like us to bring your attention to some of the global risks. The World Economic Forum has recently concluded their perception survey on some of the risks that are facing us as just countries and as regions, and as the world. You'll see that they are separated into economic, environmental, geopolitical, societal, and technological, and most of them are environmental. And we've got climate action failure, which is the leading risk that we're faced with, the fact that we are not actioning work towards reducing the impacts on climate change. And I want to draw your attention to number 8, which is natural resource crises. And that is what brings us here to this presentation. The fact that our natural resources are diminishing, being depleted, and also trying to find solutions towards just managing them. So I wanted you to be aware that these risks have recently been taken out, and our water crisis will sit within number 8, which would be assisted by number 1 if there was climate action towards reducing the impacts of climate change. Here, we want to draw your attention. This has been spoken a lot in terms of the water scarcity in the SADC region, the water security problems that we are faced as a region. And Mr. Msibi also spoke, Doc also spoke about the fact that we are experiencing a water scarcity issue, and the water market pool will really look at how we can draw resources, water resources from countries or countries that have abundance to countries that have scarcity. So here you'll see that down at the bottom where you see South Africa, we are currently approaching physical water scarcity. And this means that more than 60% of our river flows are withdrawn, which is different if you go up north where they are experiencing economic water scarcity. And that means limited access to human resources, institutional resources, and financial capital. So that is, this is important information when we start putting together the nitty-gritties of the water market pool model, because we need to know what the resources look like in the SADC region. It's important also to just look at the water energy food nexus, and this the nexus is really an approach of basically balancing our water security, energy security, and food security. Because if we do not have enough water in our catchments, in our rivers, that will directly affect our ability as a region to produce food that is enough for all of the people within our region. Also, yesterday's presentations looked a lot on the renewable energy capacity within our region, looking at hydro, looking at solar, looking at wind, etc. And that is basically, if we don't have these water resources for some of the hydro, for the floating solar, we will then not be able to close that energy security gap, especially because renewable energy is being seen as a solution towards energy security. So this balance is important for us as SADC to be able to keep in mind and to actually balance. Now, with the coming into the green engineering solutions, this speaks directly to the global risks that I put up, because we need to be sustainable in the way that we approach the work that we are doing in the water sector. We need to ensure that we are putting efforts towards climate action and towards reducing climate impacts, and that is going to help us greatly as a region. So what are green engineering solutions? It's basically the design, commercialization, and use of processes and products in a way that reduces pollution, promotes sustainability, and minimizes risk. So it's important for us to keep that definition in mind, and also to just know what principles support green engineering. And our focus on one of our case studies will be the conservation and improvement of natural ecosystems while promoting human health and well-being. But we see that some principles include striving to prevent waste. Yesterday, we spoke a lot about wastewater reuse and wastewater reclamation, minimizing the depletion of natural resources, and ensuring that all material and energy inputs and outputs are safe and are reducing impacts on climate change, and that brings in our renewable energy. So this is important for us to know just from the onset. This slide now gives an overview of some of the solutions that are available for us in the water sector. What I didn't mention in the previous slide is that green engineering solutions are not unique to the water sector, but to all sectors in general. Like I mentioned, if you see the definition, it covers all sectors. But there are specific solutions that we can harness as the water sector to ensure that we are doing things sustainably so that our resources can stretch for future generations and for their generations and their generations and so on. So if we look at this diagram, you will see that it's basically the process of water treatment, where we abstract water from our rivers and our dams within the catchment. We then pipe the water towards the water treatment works where the water is treated. Prasanta and Sashita did cover this, where you got your input, which is the raw water quality, raw water, and then you've got your treatment, and then you've got your reservoirs where you store the water, and then you've got your communities that use water. Then from the communities, we've got the water then going to wastewater treatment works where it is then treated. So if we look at number one, where we speak about rivers and our dams and our catchments, what is available there for us? I mentioned that if you look at the principles of green engineering, there's a part about conserving natural resources. So here it's looking at ecological infrastructure investment. One of the speakers spoke about the fact that we need infrastructure to be able to implement the water market pool model. So in that way, we need civil infrastructure, which is the hard infrastructure, and we then need green infrastructure, which is the ecological infrastructure. So here we've already got the infrastructure in place. All we need to do now is implement initiatives to restore this infrastructure. So that is speaking about a number of things that Dwali will cover. But basically, if you think of ecological infrastructure, it's basically replenishing our natural resources, which is the equivalent of hard infrastructure. And then we've got opportunities for hydropower. That was spoken a lot about as well in yesterday's presentations. And this is where we've got access to dams, we've got access to rivers, we've got access to transfer schemes where we can harness this hydropower. We've got opportunity for floating solar. I won't mention specifically Umgeni Water, but just as a region, we've got a number of dams with the thousands and thousands of surface area where we can actually implement surface solar and use that energy now to run our schemes and to perhaps feed back into the grid if we've got surplus. And then if you look at number two, we've got opportunity for implementing 4IR. This specific session also speaks about harnessing the fourth industrial revolution, and there's an opportunity for leak detection systems, for example, using remotely operated vehicles, which will basically be put into these pipes and be able to detect leaks and make our maintenance actually better managed, and we can benefit from that. And then when we come to number three, at the water treatment works, we've got opportunity for solar PV installations. We know that with our buildings, we've got opportunity with our car parks, etc. And then that energy can then run the water treatment works, maybe admins, and then in that way we are integrating. We heard when Prasanta and Sashita were speaking, the fact that we need backup. We need backup, we need renewable energy for us to be resilient against these floods that have been hitting us quite a lot this year and just in previous years. There's opportunity for green building. Green building is basically speaks to when the design, the construction and the operation of a building reduces impacts on the environment. So we've got opportunity to, when we are installing this infrastructure that the previous speakers were speaking about, we ensure that this infrastructure does not exacerbate climate change, but instead reduces its impacts. Rainwater harvesting is a huge opportunity. This is something that can be done in that we harvest rainwater and then we do not flush our ablutions, for example, with potable water. I was at a seminar sometime last year where the speaker was just direct in saying that if you are still flushing ablutions with potable water, then you do not understand the natural resource problem and the water problem that we're faced with. So that is something that is really something that we need to look into. There's waste recycling and then sustainable water treatment processes. We know that more and more engineering designs are going towards ensuring that the processes are energy efficient and they're not harmful. In terms of laboratory, Prasantha mentioned that we are testing water currently. There's opportunity for water efficient technology, water efficient processes, and using water that we rinse with at the labs to do other work that does not need potable water. Within our communities, environmental awareness is absolutely key, where we go out and make our communities aware of the water issues, make them aware of how they can assist in terms of taking care of rivers, taking care of dams near them, and also ensuring rainwater harvesting. And then at the water treatment works, which is now number 6 of the slide, it's ensuring that we recycle and reuse our wastewater. This was also touched on in the previous session yesterday. Earlier today as well, we said there's no water that is wastewater. So that is something to take home with us, to say how can we reuse our wastewater at the water treatment, which is not wastewater. So it is a solution to another problem. And then waste to energy. This is a big opportunity as well, where at the wastewater treatment works, we try and find ways of how we can use the waste and generate renewable energy. So this is a summary of some of what we have readily available for us. But now I will hand over to Dwali, who will zoom into ecological infrastructure investments.
Thank you, Thobekile. Yes, good morning, everyone. So I'm going to just look into ecological infrastructure investment on a particular study that was done by the Umgeni Ecological Infrastructure Partnership, which is a partnership between Umgeni Water, UKZN, and other stakeholders. This particular project is called the Umgeni Ecological Infrastructure Project. So it involved looking at certain ecological infrastructure actions, rehabilitation actions, and seeing the forecast or the estimate of how much more water we can yield from the catchment if we actually rehabilitate our catchments and we actually make sure that we get more yield out of our catchments. So I'm just going to zoom into 3 of our systems at Umgeni Water: the Midma Dam, the Inanda Dam, and the Nagel Dam. So in this investigation, the hydrological impacts were accumulated to represent the impact of rehabilitation actions, yes, on the hydrological processes. So we looked at stream flow, we looked at base flow, and sediment yield. And at each catchment, across all the catchment, and the outcome is actually the best case scenario, and there's a 50-year forecast of this best case scenario. And now these estimates, they outline the potential hydrological gains, and they're made from intensive ecological infrastructure management process. They were also used as the basis for the economic analysis that then came after. I would just like all our viewers to note that in certain catchments, the rehabilitation activities actually led to reduced stream flow due to the fact that once vegetation cover is reintroduced in an area, there may be increased transpiration and also, more importantly, a decrease in the overland flow because the vegetation will result in a higher interception of that rainwater flow, and this will possibly reduce the amount of water that ends up in the river due to the rain event, but it actually gives an opportunity for this water to infiltrate down to subsurface water and replenish our groundwater resources, and then eventually feed the river, which is what we will be calling the base flow. So this leads to an overall improved ecosystem service, and it also leads to a better ability for the catchment to manage flood events or high rainfall events. It will take us a bit longer to get to that flood level. So what you are seeing on your screen now are the results of our Midma, Inanda, and Nagle Dam projections. We can see that increased water volume from the grassland and woodland rehabilitation. I mean, there's estimate is about 100,000 meter cubed increase in water. Inanda Dam, we're looking at 818,000, and Nagle Dam is a negative of 2,600, which I explained earlier. Now, if we actually remove alien plants, because alien plants, they at times make the environment not conducive for the natural vegetation to grow and thrive. So they're actually quite a bit of a problem. So if we do activities where we remove those alien plants, we're seeing an increase in yields of 1.6 million, 44,587 in Nagle Dam. This now results in an overall percentage increase of 21% for the Midma Dam, 8% for the Inanda Dam, and 1% for the Nagle Dam. What we are looking at now is the dam catchment sediment yield. So colleagues, this is the amount of sediment that is gathered by the rain as it falls on the catchment, which is resulting in poorly vegetated catchment areas. So then the rainwater carries the sediment into the rivers, into the dams, and ends up minimizing the storage capacity of our rivers and our dams, which is a big problem at the moment in our water sector. So we can see that grassland and woodland rehabilitation would reduce this by up to 60 tons per year in the Midma catchment, about 325,000 tons per year, and Nagle Dam, we're looking at 136,000 tons. These are big numbers, and it means quite a lot to our ability to actually retain the water, be it a flood event or be it just a normal rainfall event, to meet our water needs. Alien plant removal, 5,300 reduction in the Midma Dam, 386 tons in the Inanda Dam, and 668 tons in the Nagle Dam. Overall percentage yields is really quite promising, 84% in Midma Dam, the reduction, Inanda Dam 93%, and the Nagle Dam is 86%. Now we are looking at dam catchment dry season base flow. So this is the amount of water that flows into our streams from the groundwater, which would have been replenished during the rainfall season. And because of the increased vegetation, now more of that water can actually seep down and become ground flow. So we can see an increase due to grassland rehabilitation of 182,000 in the Midma catchment, 529,000 in Inanda Dam, 525,000 in Nagle Dam, and an overall percentage increase. Midma Dam is 73%, Inanda Dam 113%, Nagle Dam a whopping 196%. And now we are looking at the costs. So in order to develop an estimate of this rehabilitation and management of these systems, grassland conditions, woodland conditions, and animal plant infestations were categorized, and the area of extent of each type of degradation was estimated in a workshop with local experts using available KZN land cover maps and local knowledge. Local knowledge, colleagues, is very critical in our sector because there's a lot of knowledge that our communities hold that sometimes don't reach us as water boards or even the academic sector. And this was also in partnership with research teams, field assessments that those teams did. So using this information and average costs per hectare that were derived from organizations that are currently undertaking rehab of degraded areas near natural conditions. Now we did this estimation that I'm about to present to you now. The costs are going to include capital costs and ongoing management costs. And please note that once again, this is for a lifespan of 50 years. So now we are looking at the grassland management capital costs. This is the revegetation. Midma Dam, over 50 years, colleagues, we're looking at 22.6 million. Inanda Dam, 22.5 million. Nagel Dam, 17.2 million rands, which is a total investment just from grassland rehabilitation of 62.4 million rand. And then the ongoing costs across the three systems, we were looking at about 1.3 million rand, and alien plant clearing capital costs, we're looking at 79.6 million rand. So if we take these figures and now we just do a rough estimate to our most recent dam construction project, which is the Spring Grove Dam, which is also on the Mgeni system. This dam cost us somewhere in the region of 582 million rand to yield 139 million meter cubed. From the presentation that I've just showed you now, we can see that we can get a competitive amount of water from investing a lot less money and rehabilitating our existing catchment area, which is a much greener approach to improving our water security than just going straight for the option of building a brand new dam or some other brand new scheme to try and solve our water scarcity problem. So now, colleagues, we want to now discuss briefly the water trading in the water market, because the theme of this symposium is really how can we trade this water so that we can get a more economic value out of the water. So basically what we've discussed already is how we can increase water use efficiency, how we can increase the amount of water that we can get into our catchment. Okay, so now we've got this water in the catchment. We've allocated the water via the normal allocation systems to make sure that all our people and all those critical water needs are met. Now that surplus water that we get, what do we do with it? That now leads me to look at, once again, the South African perspective to try and connect it to the case study that we've just presented. We've got the National Water Act that is governing our water allocation and water use in South Africa. Section 25 of this act makes provision for the transfer of water use entitlements. This means that they can be a water market in the form of permanent or temporal transfers of water use entitlements, which has been used, shown as an important mechanism through which water efficiency can be promoted. If you are able to minimize your water use, then that is what you're going to pay for. But that extra water that's been allocated to you, you now trade it on the market and you actually get more water from it. So that means the liberated water can be reallocated to the most appropriate users. This can be new users or existing water users that perhaps want to expand their operations. So we can now utilize this quite efficient way to realize the opportunity cost of water. For example, there's a study that was undertaken by Lowe, which estimated the value of water in the Berg River water management area in South Africa, KZN, from a water market perspective, looking at efficiencies and utilization of water. He estimated that one could actually trade their water for 20 rand per meter cubed, which is a lot more lucrative than the current allocative mechanisms. So water trading allows a shift of costs from those who can manage and who have the desire to creates more economic output from the water, and it's completely voluntary, which means that people are free to be as innovative and creative as possible in how they utilize this water to increase the economic output. This money that now is gained from this activity can actually be invested back into creating or implementing more water efficient processes in our water utilization, which actually helps us meet our goal of reducing our water scarcity problem. Now, I'm just showing you now because the case study has been more focused on South Africa KZN. But if we look at now, just stepping out a bit at the whole country and even SADC, we see that there's existing water sharing and there's existing water market activities already. They are ongoing, even though it's not really a water market pool, but because this market is already there, the water market pool can actually build on this. And these activities are getting accelerated due to increasing water scarcity. So trading water from one region of a country to another region of economic need can actually benefit both regions, because the one region benefits from development of infrastructure and alleviating water, and the other region benefits by alleviating water scarcity. So now, of course, there are challenges that are being experienced in the sector. For example, in South Africa, our current legislation limits intersectoral water transfers. We can transfer water for the same use or use it on the same piece of land, but for a different use, which means now if a factory or a mining operation downstream from a particular license holder wants more water, there are current limitations to that. So these would have to be overcome. And the over-allocation of catchments, the Department of Water and Sanitation has implemented and is implementing a compulsory water licensing program where people are allocated water to use or to store for whatever need they have. They are issued these licenses with conditions that state how long the license is valid for and how they can best make use of the water. Now, in South Africa, historical water allocations no longer meet our current water allocation needs. So this process allows for an evaluation of that current allocation system and perhaps creates opportunities for better allocation and better use for the water. Water markets have been proven that they are more effective when the entitlements are properly defined, well managed, and transferable, because this increases investor confidence in these markets. It's a relatively new concept, yes, and the challenges includes market inefficiencies, high transaction costs, market information adequacies, and weak or sometimes absent robust institutional frameworks to facilitate market development. So there is work that needs to be done to further develop these water markets. But I think a symposium such as this one is definitely a good starting point to get the conversation going. So colleagues, we've spoken about the green engineering solution. We've spoken about the benefits of investing in ecological infrastructure and the benefits of the water market pool. What is particularly standing out about the ecological infrastructure investment option is that we're investing in existing infrastructure, and it's a type of investment that involves our people. It's not something that needs particularly unique skills. You don't need an overabundance of expertise. And it's something that can actually be done across South Africa, across SADC, across all of Africa. And the results from the case study are quite promising, that we can get quite an increase in our yield and then be able to play more in the water market pool and realize a higher financial benefit from our water. Thank you.
Thank you so much to our speakers, and they've summarized it for themselves. And just to look at how they got us thinking about the global risks. And if you look at the map they provided, we were sitting on yellow, which means not so great, not so worse. But the rest of our Africa, especially the Central Africa, Eastern, Western, you could see the red light flashing there. And on green engineering, one thing they touched upon was maybe design and commercialization. They stressed the importance of ensuring that the changes are made at design level and with the thought of commercialization, which I think is big, because I've seen some projects wanting to start at a very late stage and hence maybe not achieving their goals. Also on green engineering, we were taken through the six-stage process that starts with the rivers, the dams, the catchment, and goes all the way to wastewater treatment works. And what I like about this diagram, it sort of gets us thinking about the interventions we need to be doing regarding 4IR and even 5IR in each of the stages, because as you go through a stage, you need to know what interventions you need to have. Like stage number 2 talks to your pipes, what do you need to have to ensure that you take advantage of the new technologies. And on ecological infrastructure investment, and from Kalisile, it's all about what has been achieved. You know, I looked at the example on grassland and woodland rehabilitation, especially on sediment yield and management and rehabilitation. The sediment yield, if you look at it, it's something that you can easily ignore. But if you pay attention and you look at it, you can see how you can recover your system and do it in a way that you become the major benefit, maybe I would say the major winner. Now, what is coming up again is the open market. No, today we are in the market of water. It's coming up to say, as Dr. Mandla Msibi gave us a nice presentation on the open market, the importance of it. Kalisile went and said, okay, this is how maybe we can look at how we can trade, and touching a bit on the countries on SADC. So that's what I found very interesting. Doc, Dr. Zibane, I would like to call on yourself to introduce our next speaker. For me, I've just looked at the impressive presentations from the ladies, and you know, and the pen keeps on writing. You know, keep on writing and writing. It's very interesting. And Doc, if you can kindly introduce the next speaker, thank you.
Thank you, Co-Chairperson. I think, colleagues, thank you very much for the presentation so far. I believe that we can have all the research, development, technology, innovation, and commercialization in terms of the water pool model. And I think what the previous speakers have done was to say we need to look from engineering approach, how engineers and solution can assist in terms of pulling up this market and make it appropriate yet affordable for households. And the next speaker then will actually address the gap in terms of the 4IR, 5th IR, the artificial intelligence, the issues around the gig economy, which is being a gap that we're going to have. Ladies and gentlemen, it is a privilege and honor to present to you Mrs. Mpho Mokopane, is the youngest female South African chartered accountant and a chief executive officer of Energy, Water Sector Education Training Authority. In South Africa, we have about 25 of those. And she is the chairperson of South African Institute of Chartered Accountants Ethics Committee, the CRTE Advisory Council Board, University of KwaZulu-Natal Council member, and Novo Energy and African Women Chartered Accountant Board Committee. She has over 15 years as a registered South African Chartered Accountant, working in public and private institutions. Her inspiring work in accounting made her an overall winner of South African Institute of Chartered Accountants 35 under 35 years in terms of age in a competition in 2019. Ladies and gentlemen, welcome our guest speaker, one of the youngest innovative presenters. You will enjoy her presentation. Thank you very much.
There's so much pressure on me. Please do let me know if my presentation is reflecting.
Ms. Mukapele, if you can just put it in slideshow view. There we go. Click there.
Is it in slide? There you go.
Yes, please proceed. You can switch off your webcam. There seems to be an issue with your webcam. There we go. Perfect. Thank you, ma'am.
And I think maybe I should switch it off. My face is disturbing me.
You can just make the webcam smaller if you would like to have your webcam on.
Thank you very much. And thank you very much to Dr. Tibane and Chair. Thank you very much. And thanks to the previous presenters. I am not, just for correction, I'm not the youngest CEO. I wish I was. Age has run with me. I was probably the youngest CEO then in the CETA space when I started. But conversation today, I don't have any technical presentation. I get excited when I sit in water symposiums and there's all these papers and numbers, and I'm often lost but excited about what we will achieve from some of these papers and some of these presentations and some of the solutions that are coming out. And mine today is really to talk to the skills that we require to ensure that we are driving. We talked about the fourth, we talked about the fifth, but really to drive industrialization of the water sector. And drive it through, when I see 4IR, for me, industrial revolution talks about a rapid change. It talks about something must shift, and it must shift radically. And our water sector is really ripe, and it's really fertile ground because of the challenges that we face in South Africa and in Africa, fertile ground for us to rapidly change without being apologetic. And so I'll talk to a number of, just a couple of areas where we could potentially, when we look at some of the solutions, some of the great thinking and some of the research that is done in our country, develop activities in our country to roll it out, so that we do not research for peer review, so that we do not research for presentations, and so that we don't research for archiving and publishing, but we research for solutions that are going to change South Africa and are going to change African social landscape. Please do let me know if the slide is not moving. Just for those who are in the room who might not know who EWCETA is, we are the Energy and Water Sector Education Training and Authority, and our role is to ensure that we are anticipating, which means to determine the skills needed in the country from a water perspective and energy perspective, manage the skills development, not project manage, but to facilitate the management of the skills development from the identified training needs, and also provide information to the sector on where these gaps are. This we don't do on our own. It's not a desktop exercise. It's an exercise that is legislated from a WSP work skills plan perspective, but over and above the legislated process of determining the skills needs in our country, we also work with a number of research houses, we work with universities, we work with employers on the research that is done to ensure that we are identifying timely skills that are required. Please note that as I present, I will constantly be making parallels between the energy sector and the water sector. We serve both the energy and the water sector, and there are a number of lessons that we can learn, and good lessons that we can learn from the energy sector, and also the mistakes that have been made in the energy sector that the water sector might learn and not repeat. Just from I'm going to hide, I've got something on my screen. From what we do, I'll focus on just the 4 pillars of our strategy. I talked about anticipating skills needs. EWCETA's role is developing a credible mechanism for identifying skills that are demanded in the country. And it's not a criticism. Often when we look at our skills that are required that in the water sector, coming from the submission from the water sector, it's often not a reflection of what we really need as a country. And I'm highlighting this because that informs our investment in qualification development, investment in learners, investment in TVET colleges. If that information is skewed and is not credible, we often find ourselves that we are training for unemployment. We train young people on skills that industry has identified as needed. And once we've trained these young people, we've funded TVET colleges and other training providers. There is no uptake from industry because industry doesn't really need such skills. So this is one area that we've been really working hard to ensure that we improve, because if we don't identify the right skills, the rest that we will be doing as a SAIEE and as a country will be futile, will be fruitless. Developing a credible skills mechanism also feeds into the critical skills list that you saw that the Department of Home Affairs publishes. And I know many of us in the room will probably not agree with what is published there from a water perspective. And the reality is it is informed by a significant portion of it is informed by what comes from the sector. There is a lot of linkages I've heard in the room from an energy and water and food nexus. There is a focus on that space from a SAIEE perspective, because we cannot look at energy in isolate. We cannot look at water in isolation, and also the food conversation cannot happen without energy and without water. The third pillar there talks to closing the scarce and critical skills gap. And what we look here is, I'm going to just highlight on skills on demand. That in the last 2 years, we've been really coming to associations and to employers, which is often it's water boards, it's irrigation boards, it's we also work with municipalities, but they are not directly levy payers to EWSAIEE, and looking at what are the actual skills that have been demanded. And we are seeing a very operational approach to skills on demand, where often what we get from the sector is how do we ensure that our operations are running, and we neglect the strategic parts, the management part, the decision making, the higher level parts, where some of the conversations that are happening require skills at that level in order for us to realize the research that we see. One of the other area in the fourth pillar there in the blue, intensify continuous professional development and career guidance. So what we do as EWSAIEE is to ensure that workers that are already qualified do not remain stagnant, that with the changing world of work, with new technologies, with shifts in markets even, and shifts in how work is done today, we ensure that we are upskilling and reskilling workers and providing those worker bursaries, funding PhDs, funding masters in the space, so that we are getting a yield in the country based on the investment that is made from such funding. I mean, we've had great partnership with some of you in the room with regards to funding postgraduate studies that will yield not only qualified people, but qualified people who are going to be producing solutions for the country. And the last one there, without inclusive economic participation in our country, it's meaningless, as we are talking about the different technologies, and we're talking about water market pools. It's very important for us to ensure that we don't drive the agenda of water market pools when we're talking about investment, that it does not become major players only, and we build a boys club that excludes other or within the economic activities in that space. So we look at positively contributing to the inclusive economic participation by supporting enterprise development and innovation in the water sector and the energy sector. So that's just a high level of what we do as EWSAIEE. And for the sake of this conversation, I thought we should just pull out a number of things that have become our strategic focus, aligned to our strategy. Also, we just pulled out a number of things where improved planning cannot be done without collaboration. This is a realization that as the sector is planning, as the sector is researching, the only way for us to improve skills planning is to collaborate with the sector that is busy with a number of initiatives. And therefore, we have partnered, our partnership is beyond, which I know SAIEEs were known for learnerships. our partnership with industries beyond learnerships. I think we were not designed for learnerships. We were not just designed, they are important, but we are not just designed for learnerships. Our focus is industry-driven learning programs. For a long time, we have run learning programs without industry. We've run learning programs where we did not include industry at planning and also at implementation. And we've seen in the past years a shift where industry is implementing more of our learning programs than where you've got non-industry players. And this is improving quality of the training, and also it's also improving a level of absorption and also improvement in the level of ability and capabilities of those who are employed. Advocacy is key in the water sector. It has been very key also in the energy sector and capacity building. Yes, we do capacity building through training, but for other stakeholders like labor unions and communities and CBOs and co-ops, we have taken a stance that if communities are not understanding the transition and the change in the world of work, we talk in the 4IR and they don't know which industrial revolution we find ourselves in, it's really pointless and it's not inclusive if we're not engaging and involving the right people. And this is where we've partnered with entities like NEDLAC to ensure that as they are engaging with communities, we are on board to talk to the water changes and water activities and areas of involvement, and for them to be aware of what is happening within the water and the energy sector. I've touched on incubation of emerging and existing enterprise. That has been really come up big because we realize that the economy is not growing. South African economy is on its knees, and it's not about to grow at a pace that is going to absorb a number of young people that are graduating. I said, if you were in the room, and I was at the DWS session last time, and we often, and I mentioned that we often look at our young people as a liability, especially the unemployed young people. Africa, the entire Africa has so many young people. It's the youngest continent actually with young people, and this is the highest number of unemployed young people. And in the next 5-10 years, the growth in economy is not going to address their needs. And if it doesn't, what's going to happen to those young people? And therefore, we're driving incubation of emerging and existing enterprises to drive innovation. It's only through innovation and through SMMEs that some of these solutions are going to be rolled out, and where jobs might be created to also just to contribute to the economy. And again, what we focus on is really projects aligned to the national imperatives. You'll see that from a climate change perspective and from the ERRP, there's a number of initiatives in the country that we have aligned ourselves to. We thought it's important to talk to the role of research because in this room, I know we've got great researchers and there's a lot of work that is done from a research perspective. And I think the biggest pain would be South Africa to produce so many great papers and never see those papers realize into something that is beneficial for our country and even to lead the world. We've got unique socio-economic challenges. We've got unique social challenges. Just yesterday, we were talking about the ESG, and water issues are underrepresented in the ESG conversation under social aspects, even under environmental aspect. Energy seems to be driving some of the measures and some of the reporting guides when it comes to the ESG, except maybe for water consumption. But there's very little that is being represented when it comes to ESG measures in the ESG matters. So what we want to look at is the role of research as EWCTA as we anticipate skills that are required to ensure that it's really informing supply and demand side for skills planning. There's great, like I said, there is great research that has been done, but what we have probably failed often to do is align skills planning and skills demand to all these other researches. So if, for example, if we are doing a water market pool research and work and studies, is a skills development leg part of it, or is it something that we'll consider when post-prototyping? Or post, and when I'm saying water market pool, I'm talking about any other research also. Post prototyping when we need to roll out. So this is what we're looking at to say partner with industry that at demand and supply research, we also at research perspective, we also talk about the demand of the skill and how that skill will be supplied. We also, from the third point there, determine funding priorities. Research that is done by the sector also aligns what the fund that we receive from the sector, where it goes. If research is indicating a shift into technology, the funding should shift towards technology so that we are capacitating the workforce and those who are unemployed. The last point there, I'm not going to go through all the points, is that we inform qualification development. You will note that I'm seeing it in the energy sector, and it might also be, it's not as prevalent in the water sector, but a number of on-demand qualifications or on-demand training or skills. Often the qualification is not available in South Africa. And what we are seeing, as I said, I'll draw parallels with the energy sector. In the energy sector, only those who can afford international training have access to the international courses, and we leave a lot of people behind because they can't access those international courses. So what we've done as EWC is we have looked at some of the international courses together with industry, and I'm using the energy sector as an example to say which of these are needed in South Africa, and how do we not reinvent the wheel, but how do we localize it? And it takes forever to develop a qualification, and therefore we have resorted to short courses. How do we develop skills programs to respond to the demand on time, and how do we also fund short courses to ensure that the sector is updated and all people have access to being trained and to be upskilled. And this indicated below really requires that we partner, we cooperate, and we put together our heads and our funds so that we see meaningful impact. There's a lot of us who are in this room who are doing training. Most of us are doing training, most of us have academies. And if we stand on the side and still look at the challenges that South Africa have, from a water perspective, it looks like we're not, we might look like we're not making the dent that we are required to make, and the dent that we would probably make if we collaborated in spending such funds. So skills development consideration, and the questions that I've just raised here is that are we responding to the specific needs of our sector, of the water sector, as we are doing training? And this is for all of us in the room. And this is for all of us as we research also. Always I said, if you're researching, please put there, even if it's at the end of your paper, the skills that are going to be required to ensure that those solutions are implementable. Skilling for the past or skilling that we need now and in the future. Biggest challenge in South Africa is to skill for the future. We're good at skilling for now because we've got current issues now, and it's also difficult to balance. How do I skill for the future if my future is not certain? If you've got policy and decisions that are not being made and dependent on maybe government, and those decisions are not being made, when you've got infrastructure decisions that needs to be made and aren't made, investment that needs to be made and is not made, how do you skill for the future and not have a cohort of people who are capacitated but cannot apply their skills because decisions on the ground are not moving with the times. So that's one of the key things. How do we skill for the future? And this requires us to, even from a skills development perspective, look at no regret skilling. We skill people for the future, but we make sure that it's broad enough that should a certain direction not be taken, these skills can still be used in another sub-industry. Also implementing the right skills and in the right place and at the right time. This assists us in avoiding importing skills when we demand them at a time. And also it really talks to proper skills planning. Transitioning to a new world of work, there was a mention of the gig economy. We are realizing in this specifically, and I say from an energy sector, from a renewable energy perspective, the number of jobs that are going to be created by the renewable energy are not the same as the number of jobs that are coming from the fossil fuel, and they are also not long-term jobs, it's gigs. Gigs at installation, and beyond installation, there's no requirement for significant number of people to maintain solar panels or wind farms. So what type of jobs, what type of work are we seeing in the future in the water sector? Is it permanent jobs or is it permanent jobs or is it gigs? And that also will inform how we train people. We train people for multiple gigs, yes, with base qualification, so that they are able to respond to different spaces, and also to be able to work across different countries and different continents. The third last point there, preparing people to make an impact on society, and I'll talk to it in the next slide. Also, we look at how, when we, from a skills development consideration, are we training people to be qualified, or are we training people to make an impact? And this also come from basic education. At basic education perspective, are we training people so that when they are outside, they are just seeking employment, or are we training people that even when they've sought employment, are employed, are bringing solution to employers, or when not employed, are bringing solutions as innovators? And lastly, I'll just touch there, are we opening our workplaces for the purpose of work integrated learning? There's no way we're going to have people who are creative and innovative if they don't know how workplaces operate. If they've never been exposed to virtual reality, we cannot expect them to be creative with VR if they don't know how that looks. And I know I've said this before, the water sector, most of the areas where there's quality training or exposure to work experiential learning is in the water boards. And are the water boards open beyond their academies? Are we open to TVET colleges that are studying water and are sitting and doing practical, but have never seen how things are done in the workplace? And if we don't consider some of those things, it's really, we are continuing to produce a number of people who are going to be seeking employment, and even after obtaining employment, not resulting in the impact that we would like to see. Just to skip these two slides, I'm very mindful of time. From a response that is required, if we were to look at the technologies that have been presented, we were going to look at the water market pools, and someone also talked to the disruptive model. And as I said, that the water sector is ripe for disruption. I don't think we will lose a lot if we disrupt how we do things, but I think there's a lot to gain. We need to identify and increase production of priority occupation. And the question is that, do we have a list of priority occupation to drive some of the innovation? If we were to industrialize the water sector, if we were to revolutionize the water sector, do we know the priority skills and occupations that are required? Ours is also to encourage the research and development so that we enhance technological innovation. As I said, if people do not have access to that technology, whether it's in the workplace or it's in the TVET spaces or in the PSET system, if they don't have access to it, how do we expect innovation from even employees and from those who are in schools? What we also want to look at is increased worker participation in reskilling and upskilling. Solutions, most of the solutions in the water sector will also come from the workers. It's those who are in the industry who are seeing opportunities, who will be able to drive industrialization of the water sector, and therefore they need to be capacitated and exposed, and whether it's local or international exposure, they need to be exposed and capacitated and upskilled to ensure that we are driving that industrialization. I've already talked to the fact that the response, what we require is also to enhance research efforts through collaborative research. Whether it's local, whether it's regional, and whether it's international, we require that. And just my last two slides, I'm going to talk about the future of skills. I'm sure we can come here and list all the different occupations that are going to drive the sector, and I'm just going to touch on over and above some of those occupations. The shift that is desired by the water sector and some of the presentations that we've had in the last three presenters, there's specific skills that are going to be required. And the first one that I highlighted is the regulation and policy setting and interpretation. The energy sector is struggling and often stuck at this space, at this stage. From a regulation and policy perspective and interpretation of policies, we have decisions that are made, and I'm going to use an example with the power pools that we have. We've got IPPs that have can generate 100 megawatts, but the regulations around wheeling and onto the grid, the pricing was not done at the right time, and therefore delays in implementation, a number of challenges with regards to implementing those power pool the IPP agreements, and they generate but can't load, has resulted in some delays. And therefore the water sector, as we wanting to design water markets, we need to start thinking about what are the type of regulation, what are the type of policies, what are the type of pricing, even in those spaces. And therefore, there's a skill that is going to be required in the regulatory space. From a data collection analysis and interpretation perspective, we sometimes downplay this, but we cannot talk about water and not talk about data collection. There is going to be a critical skill that is required. We might already have some of these skills. Geopolitical risk and regional and global thinking. As we are wanting to deal with within the SADC region and maybe even growing beyond SADC, we need to have the skills to be able to manage the geopolitical risks and also to look at regional, that is not very properly spelled there, and global thinking. Ethical leadership. There's some people say it's not a skill. I don't know if it's a skill or it's a virtue, but there is a great need for ethical leadership if you're going to trade with water. This is where you've got countries that need to be considerate of certain, someone's talking about where you don't need water, you're able to let it, you shift it to another area. This requires ethical leadership where people are not thinking for themselves and where it's not led by greed, where we're not led by securing water for your own space only. Water financing is going to be critical. How do we deal with water? How do we, within that market, what are the requirements and what skills will we be requiring to ensure that we are marketing and financing water? And also from a solution-driven education and training, we cannot continue to be training for the sake of qualification. It's really need to be you training people to be solution creators. And also the skill to drive sustainability and inclusion. I've brought this because I'm seeing it as a challenge in the energy sector. Driving sustainability and inclusion. When setting policies, we need to be very cognizant of certain policies when we're trying to drive sustainability can exclude certain players. And I'm going to give an example within the energy sector where we are seeing green financing, where you've got an energy mix in South Africa that still have fossil fuel, and you've got fossil fuel players. And the green financing requirements indirectly exclude small players. And where you often see that players in the space become big investors, international investors, and we try to bring local players through local content, through BEE. So we need to be very careful that even as we are setting the water sector to move in a specific direction, that we look at our policies that is going to drive sustainability and inclusion. And of course, the new qualifications that include trading of water and economics of water. And then lastly, just my last slide. There, I have brought this and I've borrowed it from a current study that is done by Sania and Vets Real. It's in progress. I've borrowed this from that current study. And we label it soft skills, but for me, these are some of the critical skills, future skills that we require. And in this study, we looked at the soft skills that are going to be required for decarbonization, for digitalization, for decentralization, and for market structures. And top of the list came thinking local. And one of the biggest risks that we run as South Africa and Africa is borrowing international standards and failing to localize them for Africa and for South Africa. And therefore, there's a great need for a skill to think local, a skill to think transformation and transitional thinking. We are a developing country, emerging markets, and we often borrow from developed and established markets. And therefore, we need to embed in what we do and in policies that we set that we are transforming and we are transitioning. Problem solving, which I've talked to, and complexity. One of the big things, the ability to deal with complexity and strategic thinking. I'll deal with those together. The future of skills, the future skills that we require is ability to deal with complexity. If we're going to talk about water market pools, if we're going to talk about ecological infrastructure, we probably need to be embedding even now the ability to deal with things that are complex and not be stuck for 3 years trying to study a complex situation and doing study after study and never getting to a solution. Governance and leadership, I've already talked to ethical leadership. If we are going to be trading in water from a water market pool, we need solid and clear governance and proper partnership development, where we've got people who are able in our country to develop partnerships that are mutual, beneficial to all parties, and that are not going to be, I must find the right English, but partnerships from a financing perspective and from a water perspective that are not going to be to the detriment of weaker partners. And there is definitely going to be a significant need for skills to negotiate. And these are not skills that we often see. We don't, sometimes even in our qualifications, we don't see this, but these are critical skills that we are starting to embed in our qualifications, and we're saying are required for the sector, the two sector, which is the energy and the water sector, to be successful. What we've done at EWCTA is that because we've realized that this was a great need, we have significantly focused on executive development courses, so that we are driving some of these skills, and we're embedding some of these skills in the sectors that we serve. Chairperson, I've already touched on the role of the CETA. I think I've already repeated a number of the things from a translating research on the green skills, research on industrial engineering, which is done by the sector, into education pathways. Also building institutional capacity so that there's uptake and implementation and commercialization of research. And beyond commercialization, the last part, they build capacity to drive and roll out technologies beyond prototypes. And ultimately also link the PSET system, specifically TVET, to university research, and do that at the right time. Thank you, Chairperson, for the time, and trust I didn't take much of the time.
Thank you very much, Ms. Mokopal. I think in summary, you have highlighted a number of issues regarding the skills and the skills gap, current and in future, driven by 4IR. The Internet of Things, the big data that is required. You also have highlighted the 5 pillars the EWCTA is fitting in or proposing as a implementation plan in terms of performance culture, addressing the demands that are required, particularly in the water and energy and food production processes driven by 4IR. The critical skills that are required. I'm more interested also on the place that of saying that you have emphasized the need of partnerships between the universities, the TVET colleges, as well as the water utilities and municipalities. Very important about that point is that research, development, technology, innovation, and commercialization must be linked to the new world that we're talking about, and the readiness of institutions to deliver on the water mandate as well as the energy. Remember, the presentation by Gwalisi Lekunene also raised the notion that how do we address the matter of policy that is related to the SADC region and linkages in terms of policy, in terms of water performance and so forth. So I think, to me, now that we have raised that issue, the biggest gap of this today, the topic once more is about municipal freshwater market pool. And we needed to have a specialist that can talk about what are the challenges that we are faced with practically in terms of water marketing and trade, as well as water opportunities and investment opportunities that are there. And one of those is Kevin Meir, who is a graduate with MSc in agricultural engineering from the University of KwaZulu-Natal in South Africa. And he worked in consulting environment for years and became a professional engineer. He then joined Umgen Water as a planning engineer in 2005 and is now the manager of planning services department, where he heads up a team of engineers and hydrologists. Mr. Kevin is going to present issues around non-revenue water. Can I hand over to you?
Good evening, everybody. Good evening. Yes, this certainly isn't evening, but good afternoon. I'll just present my screen quickly. Let me know when you can see it, please. Okay, I trust that you can see the screen.
Mr. Mayor, if you can just swap your display settings.
Okay.
If you go to the top, yes. You have two screens, I assume.
Sorry, yes, I have, but I think I'll just.
There we
I have
go.
swapped it, but it didn't seem to work.
Proceed.
Okay, can you see it clearly?
Yes, it's perfect. Thank you.
Okay. Good afternoon, everybody, and so I'll just be presenting now quickly on a community-based initiative that we have developed at Mgeni Water to address water loss within unmetered low-income communities. My colleague Ntutuko Ngamu is away at the moment, unfortunately, on some study leave, so I'll be presenting by myself today. But I'd like to just acknowledge that this is an Mgeni Water project, but is in support of the KwaZulu-Natal Water Conservation Water Demand Management Support Program, which is initiated by the Department of Water and Sanitation, but we have a partner in the Department of Cooperative Governance and Traditional Affairs. And this program looks at the water loss or the water demand management initiatives that can be implemented in 14 KwaZulu-Natal WSAs in the province. The project that I'm going to be presenting on is a project that we have appointed a PSP AB projects and a local CPG partner of PT Flubi project managers. So just in recognition of those parties. The Mgeni Water operational area is shown in this slide, and you can see that that it takes up a fair portion of KwaZulu-Natal. We don't supply all of those areas within our operational area. We supply specifically the blue areas, and you can see the red areas shown in this map in our operational area are areas that we would like to supply in the future. So those are considered areas of growth for us, and we would expect to move into those areas. But to do that, we need to ensure that we have the correct resources and infrastructure available to supply those areas. I'm going to speak specifically about the. Yes.
Sorry, your presentation is not in presentation mode. We can't really see the map clearly. If you can just go to slideshow.
Yeah. Sorry.
If you, on the minus at the bottom of your screen, on the right, next to 62%, just click on the slideshow view at the bottom of the PowerPoint software.
Just let me know if it's on full screen mode, please.
Nothing is happening at the moment.
Press F5.
Yeah, it certainly is on my side. I'm just going to escape, and I'm just going to close it for now, and then I'll just open it.
Yeah, just swap the presenter view and slideshow there.
Please let me know if it comes through now.
Yes, that's perfect. Thank you.
Okay, apologies for that. Yeah, I was under the impression it was working, but I've got two screens. I've turned the one off, so that should improve things now. So my talk's going to be specifically about the Mgeni system, which is the largest system that we as Mgeni Water supply into. It consists of the Mgeni River and the Mzimvuzi River, and there's also a small interbasin transfer which comes from this area, which is the Moi catchment, and water is transferred from that Moi catchment down into into the Mgeni system as well. So if we have a look at a schematic of this area, you'll be able to see that there are a number of dams down the Mgeni system. These are large dams for us, and we supply the cities of Pietermaritzburg and Durban, and also almost all the towns in between those. But we also supply areas in the Mooi River catchment from these water resources as well. Now, just to give an understanding of some of the complexities that we have at Mgeni Water and some of the concerns that have risen over the last number of years, and I'm sure they are similar to what the Vaal is experiencing at the moment. This is the yield that we have for the Mgeni system, and you can see here the MMTS1. That's the traditional system before we brought the interbasin transfer scheme through. We added the Springgrove Dam, which is our interbasin transfer, and we increased the yield up to this value over here. That's the blue value. But this blue line that you should be able to see with my arrow over here, that's the historical demand. And you can see that the demand is above our assured yield and up to 200 megaliters per day above the assured yield. So what this means is that when the dams are full as they are now, we don't really have a problem supplying the resource, the amount of water that's available. But if we had a 1 in 50 or 1 in 100-year drought, we certainly wouldn't be able to provide the water that we need. And this becomes a problem for us and for the WSAs that we supply into. So you can see with that, we're currently running at about a 1 in 20-year assurance level. That means the worst droughts in 20 years, we won't be able to supply the amount of water that we are required to, although we are expected to guarantee a 1 in 100-year assurance. So we're already supplying way more water than we should be. The table here then goes further than that. So if we look at the resource, we recognize that the resource is a problem, but this is our infrastructure. So these are all the water treatment plants, the major water treatment plants that Mgeni Water supplies from. And the column in the second last column over here, the areas that are in green means that we are supplying from those water treatment plants at below the optimal operating level, which is great. It means that we can supply the water and we don't get ourselves into trouble. But the areas highlighted in yellow means that we are actually supplying above the optimal operating level, but we're supplying below the design capacity of the water treatment plant. The areas in orange, however, are showing that we are supplying above even the design capacity of those water treatment plants. So that is a concern for us. And more a concern is that the peak demands, which is shown in the last column, all of our water treatment plants supply water at above the design capacity during peaks. And that is a huge concern. So for one, we have a water resource problem, but two, we also have an infrastructure problem. And this really is the reason why we have those problems at the moment. And this is just an example for eThekwini Metro, but I can show the same trend for all of the WSAs that we supply water into. And you can see here, if we go back on the graph, we go back to 2017, the total amount of water that we were required to supply to eThekwini, or not us, but the total amount of water that eThekwini supplied was 848 megaliters per day. That was in 2017. This has already risen to 1,098 megaliters per day. And the various components that make up that are shown over here. So demand from consumers has gone from 596 to 618 megaliters per day. So that's hardly increased. But where the major increase has been is in the real losses. So real losses from 2017 has gone from 252 megaliters per day right up to 480 megaliters per day. And that's more than 200 megaliters per day of unexpected, if you want to put it that way, unexpected demand increase. And it's an increase in not real demand, it's an increase in water loss. And because of that, our resources placed under pressure and Umgeni Water, as the bulk water provider, is placed under pressure from an infrastructure point of view as well. So that needs to be taken into consideration. We are in a huge problem at the moment with our WSAs not being able to control their water loss in many instances. I'm not saying all, but many of them aren't. And this is an exact case in point as to why the VAL is also having a problem at the moment. So what we also need to recognize is that water loss in low-cost housing areas is also it's not the only problem. It's not the reason why we have those huge water loss figures, but it is also one of the contributing factors. So most of the WSAs in KwaZulu-Natal have a policy of either not metering their residents or metering but not billing their residents. And when you don't meter or bill, then the residents don't value the water as they would if they were actually paying money for it. So you end up in a position where the communities can see a leaking tap, but because it's not costing them any money, they actually don't notify authorities about it, or if the taps are leaking internally within their house, they don't see the need to actually address the problem because they aren't paying for the water. If you're not paying for the water, why fix the leaking tap? Why fix the leaking system? And that then becomes a compounding problem in these low-cost areas. So we looked at one low-cost community in our operational area. It's the Mpopomeni township or town, which is just outside of Howick. And we looked at implementing a community initiative to try and address water loss in the area. So the objectives of the project would be to assess the impact of water losses in the small community, to then develop a local project team to educate the community on the value of water, and then to train plumbers to identify and address internal and external water loss within that community. And we were hoping to highlight to WSAs the impact of not billing consumers and the potential for addressing water loss through a community-driven initiative. But that final portion over there, we would only be able to see if this project was successful. Then we could highlight to the WSAs the value of a project such as this. We appointed a PSP this year to develop a community team and then to measure and address the water loss. There are 6,500 houses in Mpopomeni. And the project would then employ 12 local residents as employees to the project. 4 of them would be trained up as plumbers, and then there would be 8 field workers to assist as well. It's a 12-month project which would end in February 2023, and the total cost of the project is 2.6 million rand at present. There are a couple of variations, but they aren't significant. So that's essentially the price that you're looking at to implement a community initiative such as this for 6,500 houses. Although, as I mentioned, because the project's only finishing in February 2023, we don't yet know the success of the project, but we believe it will be successful, and I'll show you why in a minute. So this is Mpopomeni town, and you can see the area in purple over there are the formerly reticulated areas, and the areas outside of that are in a shade of cream. All of these areas, those are areas of Ingonyama Trust land where the community members have built houses, but it's not controlled. There aren't pipelines going to those houses to supply them with water, and there also aren't formal roads to those houses or anything like that. So essentially this purple area here is the area that we were considering. That is the formal residential area, and that's the area where pipelines are taken into properties, into residential houses, if you want. We did a estimate based on the stats figures which have recently come out on what the theoretical demand should be for Mpopomeni town. So there are 6,500 houses, and if we looked at 800 liters per house per day, then the theoretical demand with a 20% water loss should be 6.5 megaliters per day, and that gives us a baseline on which to work. The total demand for the non-reticulated areas should be about 0.9 megalitres per day, but as I mentioned, there isn't water going to those houses anyway, so that's not part of this project, but just to give you an idea of what the total values would be. One of the considerations which we picked up immediately when we started looking at the billing data for this area, there are meters outside every one of the houses within Mpopomeni, but you can see here that the municipality doesn't build on metered consumption. They build the residents based on an assumed consumption, and in this case, for these 3 houses that I've highlighted, the assumed consumption is 0.298 kilolitres per day. Although we know from the figures that are out there that the houses are consuming well in excess of 1 kiloliter a day. So this is already one of the areas that we have identified. We have metered communities, but the community members aren't billed based on that metered consumption. And as a result, if we look at the meters going into the area, and this is not going to a reservoir, this is just going into Mpopomeni itself, and we look at the metered flow over a period of time, I think this is about a week that we're showing here, you can see these little dips over here, those are night flows. So night flows is the amount of water going to the community in the middle of the night, and this lowest figure would probably be at about 2 o'clock in the morning. And you can see that that figure there is already sitting at, in this case, probably about 143 kiloliters per hour. And the maximum demand is 167 kiloliters per hour. So you can see the night flow, which is an indication of the water loss because people don't use water at 2 o'clock in the morning. You can see the night flow is already a huge component of the total demand in the community. That's the 1 meter. There are 2 meters going into this area, and this is the 2nd meter, and you can see a similar scenario here where the water loss figures are so close to the total demand that the community is actually only getting a very, very small portion of the total water that's supplied to the area. If we have a look at the average daily flow to Mpopomeni, it's 9.3 megalitres per day, and the average night flow is 8.4 megalitres per day. So 90% of the water that we're putting into Mpopomeni at the moment is actually going into the ground or going down the toilet, down the drains into the wastewater treatment process. So the community itself is only getting 0.9 megalitres per day of water, and that means that those community members are actually not getting the water that they require. And that is a huge concern for us, and it must be for them. I mean, they must be crying for water there, but they aren't getting the water because of the losses in the system. And in inverted commas, you could say that the community is their own worst enemy because they haven't addressed the water loss problem and they wait for the municipality to address it. They actually don't get the water that they require in their households as well. I don't believe that it's a community problem. I believe that it's how water is supplied and the rules that have been set up on how to provide water and what the poor WSAs have to try and work in to get this water. But it does mean that even the theoretical demand, which had a 20% loss on it, is still way below the amount of water that's going to Mpopomeni. And yet in Mpopomeni, the people are actually only getting 0.9 megalitres per day, and 8.4 was going to a loss figure. So our project looked at a number of components. The first was an initiation meeting where we got the community members together and brought them on side and said, okay, well, this is the project that we're going to be implementing to see how much, to see whether we can reduce the amount of loss in the area and whether we can get more water to residents as a result of reducing this loss. And these are just photos showing the initiation. We also created media and we created a media campaign with awareness, and these flyers were developed by the PSP and were handed out to residents on, why we should be fixing a leaking tap, how to save water, why water is valuable. So all of these posters, or not posters, but these flyers were developed and have been handed out to residents within the township. Okay, so, and yeah, those are just, we also trained up a number of field workers and plumbers, as mentioned. There were 12 in total, and this is just the community members that were selected and were trained up for the project at the beginning of their training. There was a community awareness campaign where these 12 community members went around to every house and indicated to the residents what the value of water is and why water needs to be saved. And they were also, so aside from the education aspect, the plumbers were also able to then go into the properties to assess whether there were any water leaks in the area. And as part of that leak detection, you can see some of the challenges that are posed. So we have completely broken toilets and broken systems. We have taps that are leaking within the houses. We have running water all over the place. Outside of the houses, the meters are broken and they are, you know, the water is flowing. You can see this underground leak in the far corner over here. The amount of water coming out of there, that's kiloliters and kiloliters a day. That's just flowing down the local stream. And this is additional information, additional leaks that were picked up. And you can see here, there's a pipe that's just spraying water into the air. Again, we've got underground leaks. We've got pipes that were broken on the wall, and you can see the community have actually tried to tie these off with rubber bands or leather or something, and try to address it in that way. And then as these plumbers went through, then after assessing the leaks, they were able to start repairing some of these problems. So you can see here, there was a pipe that was completely broken off the wall, and when these community members went there, the water was actually just pouring out and it wasn't going into the house. So they were able to provide a fitting and join that pipe. And the same in this instance where there was a T-joint that was leaking. Again, there was a complete tap that was missing and the water was just flowing straight out of this every time that resident turned on their tap at their meter. So again, the local community members were able to just include a tap onto this broken pipe, and then they were able to get that water there. Here's an elbow that was completely damaged and was just pouring water out into the ground, and that elbow was replaced. Again, there was a elbow that was pulled off, and you can see the water just pouring out of that pipe, and then the plumbers were able to fix that. A similar instance, and I'll just flick through these quite quickly to just show you some of the repairs that were done. So here a new T-joint was created and the tap was fitted for that resident. This was a standpipe, and the standpipe had been broken. It had no tap at all in it, and you can see all day long that water was just pouring out of the standpipe and created a small river, and you can see the lush vegetation that's growing around there because of all the water that's been coming out of the standpipe. But this one standpipe is probably leaking, I don't know, 0.5 megaliters per day just by itself. So by putting a tap on it, it's, you know, they were able to address that leak. Here's a broken pipe, and the pipe was fixed with a fitting. Some of the unanticipated variations that we've had on the project, you can see there are 704 houses that have got completely broken systems, or the systems were leaking, and of those 306 complete systems have to be replaced, and the internal components of 310 systems have to be replaced. Now, you may not know, but if the system is broken, that water just pours out of that pipe straight into the toilet and goes straight down the sewer system. And that can be a number of kiloliters a day. And that's what I mentioned earlier on. If the community members aren't paying for the water, they don't understand that is a problem and that needs to be addressed. So, you know, how we change that mindset, because once these plumbers are moved off-site, you know, they aren't going to be there, and the same problems are going to arise over the next years unless the WSA or somebody decides to come up with a plan to keep these plumbers on board and allow them to go through and do these internal assessments at houses all the time. But this is a variation on the project, and this is probably going to cost 100 or 200,000 rand for us to assist in fixing, to replace these broken systems. When we first started the project, we thought that we would be replacing worn washers, but not the entire system or the system components. We also have valves and damaged toilets, structures, etc. And these all have a negative effect on the wastewater treatment, because clean water going into the system is actually not great for wastewater treatment. In conclusion, we are looking at this as a community initiative, and we're hoping that by developing this, we can identify a means of expanding this to other communities and addressing this large water loss component that can arise in local communities. The approximate cost would be equivalent to 500 rand per housing unit, based on the 2.6 million rand that we're having to invest for 6,500 houses. But the cost is likely to reduce over time. So once Mpophomeni is fully addressed in this project, you know, you wouldn't require that kind of investment every 12 months. But water loss incidents can be addressed if residents understand the value of water, and I think that is one of the takeaways that we have to try and impress on these local residents in Mpophomeni. But thank you very much for your time, and I hope you've appreciated the talk. Just to also mention that we don't have at this stage any conclusions of how much water has been saved, because the project hasn't been concluded, but we will have that in the next 6 months or so. But thank you very much.
Thank you very much, Kevin. And I hope in terms of our understanding is that the dealing with the water loss and non-revenue water is very, very key in South Africa. We are sitting at 45% in all 144 water service authorities. I've taken note of Mpophomeni town. The issues of billing demands will need to move towards smart metering system. The unanticipated variation should be considered. I think there's already a benchmark of 500 per household per unit, which you have highlighted. And I think in those few words, we'd like to check if there are few questions to all the panelists. However, I prefer, because of time on our side, I would prefer that we...
Let's take the questions.
Yeah, let's take the few questions.
Just press your question box.
What?
Question box.
Which one? This one?
Yeah, you'll see.
Okay. Question for Prashanta, in regard to water treatment, what are the new technologies that Umgen Water is now implementing or planning to implement? E.g., to what extent exactly do we make use of ozone at our water and wastewater treatment plants? In regard, I ran away. Yeah, okay. In regard to residual with ozoning, as well as odor issues experienced during the drought and flood, as well as reducing the volume of coloration. I think this person is raising this question because of the carte blanche type of video that was played, I think 3 weeks ago. And I think that's the first question, Prasanti and your colleagues. The second question, there's no other question except that one. Yeah, so that's the only question. I think it's the process matter.
Yeah, below it, there's another one.
Oh, sorry?
Yeah, let them answer that first one.
Can you answer the first one, Prasanti?
Sorry, Dr. Sibani, can you please repeat the question?
Dr. Sibani, let me help here. The question is, in regards to water treatment, what are the new technologies that Umgeni Water is now implementing or planning to implement? This is a question from Nathaniel Pariachi. For example, he's saying, to what extent exactly do we make use of ozone at our WTWs in regards to trying to deal with taste and odor issues experienced during drought and flood, as well as reducing the volume of chlorinization required for disinfection, i.e. dose chlorine just to maintain chlorine residual, with ozone being primary disinfectant. Similarly, what are the options to Umgeni Water for coagulants and flocculants that are kinder to the environment and the consumers? That is a mouthful.
I'll allow Prasanta to go first, and then I'll follow up.
Okay, hi Nathaniel, thank you for the question. We do use ozone at some of our treatment plants at our Wiggins, which is one of our larger treatment plants here in KZN, which assists with dealing with those issues. We also have activated carbon, which assists us with taste and odor, not necessarily a new technology, but one that's proven to work.
Yeah, like I mentioned also in the presentation, we have these technologies which are very effective, especially our activated carbon, ozone, chlorine, and so on, to deal with these issues. The main problem is some of our treatment plants don't usually have these sort of problems, taste and odor. And when we have drought or floods and we suddenly faced with these contaminants in our raw water, then we need to react quickly. That's the reason we mentioned just-in-time treatment processes, which we need to look at. The coagulants that we're using as well has been proven to be effective. The recent drought and the floods as well that we had in April, we managed to maintain our water quality within the SANS limits. As for environmentally friendly coagulants, I'd be interested to know about some of those. Maybe if you can share with us some of that information, and something that we can probably look into. Thanks very much.
It reads, for me, I will summarize it. In regards to policing of wastewater use licenses, that is theft of water, how do we look at control or limit the unauthorized abstraction of raw water from the rivers, streams, dams, lakes, and all other water sources? Kolisile?
Okay, I can answer that if you prefer.
Yeah.
Okay, go for it. As brief as possible, Kevin.
Yes, so the water licensing is the domain of the Department of Water and Sanitation. They undertake a verification and a process, every few years to check that the correct amount of water is being abstracted based on the licensed amount, and that verification process then would highlight whether there need to be charges or anything else laid against the licensee for breaching that, if they were breaching it. But that is something which the department is supposed to be doing. It. They haven't been doing it as much as they should have over the last few years, but I understand that the process is being started again, so that VMV process should be up and running soon.
Thank you very much, Kevin. The next question is regarding the paradigm shift in the training in the water sector. And I think the next question to that, embedded to that question, is the issue to say, how do we use the case of Mpopeni as a pilot to utilize water boards to assist water service authorities? I think that's the gist of the both of you. I think Kevin have answered that question, but I think Mpo, if you have an input, please highlight briefly for us.
Thank you. Can you hear me? It says I'm muted. you hear me, Dr. Tsibane?
Yes, we can hear you loud and
Thank you.
clear.
Thanks. Just to clarify the question with regards to the Mpopeni project, is your question how can the water boards partner to assist? Just for clarity of the question.
The question is that there is a lot of training taking place in South Africa. And the colleague is saying we need a paradigm shift where we address core critical areas of operation and maintenance. And I think the case that was presented by Kevin was answering that question, but you can highlight if there is any issue that you want to add.
Actually, I just took note of, I was just talking to Sion on the side, and I said Mpopeni is actually a good example that we probably need to also just ride on as an example. But I think it's a fact that there's a lot of training that's happening, and there's already, and I'm going to give an example. We know a couple of years ago there was about 10,000 plumbers that were trained to fix leaks. But the lack of coordination between where the leaks, is it a municipality's responsibility? Is it the water board? Is it individuals' responsibility? Just the lack of coordination from us, and I'm saying us from a leadership perspective on how these are implemented, is one of the biggest challenge.
Yeah.
I think I don't repeat what I've said, and I think also not to just, I think Kevin has addressed it, but it's really coordination of properly training on time for something. Also not training to close a problem now. It's to say what is sustainable training that will result in even the right equipment being purchased, even including advocacy communities understanding the value of water, so that we are reducing the number of challenges, so that we stop training to respond to those issues.
Okay. There's a follow-up.
I want to follow up. We were discussing this yesterday in our innovation and technology task team board, Prosperity. Kevin, I cited you to say this must be escalated to the higher authorities, because this technology is wanted by the ministry to assist everybody in the country. Now, Umgeni Water is touted as having this technology, but I don't know myself whether we have it or we don't have it. So what is the escalation route from today to say it is going to be coming to my office? We are taking it to Starkey, we are taking it to Deputy Minister Mashaba next week, and so forth, so that we know how many millions of rands are wanted. The minister is prepared, and the Deputy Minister are prepared to go through even funding options that are available at their disposal as the politicians. But we are busy maybe crying somewhere in a corner as a little child. The thing has not been built up.
There's your answer. Thank you, Mpo. Thank you, Dr. Sipho Manana. Dr. Sipho Manana is an acting CE for Umgeni Water. Colleagues, moving forward now, we have finished the speakers and the questions. I have asked Siona Riku as well as Klengi Wekele to summarize the proceeding. Do you have a presentation to make? Few minutes, in other words, less than 3 minutes, summary of the proceeding of the day before I hand over to Professor Pat Naidu for the way forward.
Close the questions on your side.
Yeah. Reporters. Okay. Can we then, in the absence of the reporters, may I then request? I think it is. Yes. May I then request? Yeah. May I then request Professor Naidu to summarize the way forward? Thank you.
We'll put your mic off.
Thank you. Thank you. Thank you.
Dr. Tabani, I am here.
We want sort of mainstreaming of gender in the water sector. Yeah, come in, Siona.
Thank you, Dr. Tabani. Good afternoon, colleagues. Just to summarize on the events for today. The water security is impacted by several factors from a global and local perspective. And these factors include infrastructure, asset management, climate change in terms of the effects of floods and droughts, non-revenue water through the water losses, we've had our presenters show us the advantages of using fourth industrial revolution or fifth industrial revolution technologies and innovations in terms of the employing of Internet of Things and big data throughout the water value chain, which is the inputs, process, and outputs of the water value chain. And it's basically summarized that the innovation and technology will aid in an adaptive capacity in the water sector and trigger faster responses to climate change activities and water losses. Green engineering solutions will play a vital role in restoring ecological balance and the water security. The water market pool is a disruptive model for water security. And it basically functions on the use of big data. And as the water sector or research proceeds towards the water market pool or the implementation of fourth industrial revolution and fifth industrial revolution solutions, the skills requirements must not be neglected, as we will have solutions that will lack implementation. And as we transition to water as a sustainable business, we must ensure inclusivity. Thank you, Dr. Tabani.
Thank you, colleagues. Thank you, colleagues.
Somebody has their microphone on there in the same room there, Dr. Tabani. So that's why it echoes for Dr. Naidu. Please proceed, Dr. Naidu.
Thank you. Thank you. Thank you. Thank you, colleagues. Can you hear me, Demings? Am I clear?
Yes, loud and clear. Thank you. Please proceed. Okay, now we can't hear you.
Am I clear? Am I coming through?
Yes, you are. Clear. Thank you.
Mings, our boss, can you confirm?
Yes, I can. I can hear you, Prof. Naidu.
What do you do? Let me come sit there by you.
Yeah.
No, we can hear you. Apologies, attendees. We have a gremlin in the issue. We are busy sorting that out. Please bear with us for the next few minutes.
Minx, can you hear us?
Yes, I can. Please proceed. Dr. Naidu, can you hear us? I mean, me.
It's on.
Yeah, Minx, just give us a moment. We getting sorry about this. Give us a moment.
No problem.
Thank you. Thank you. Just give us a moment. We're coming through. It's Minx, can you pick us up now?
Yes, I can hear you. I can see you.
Can you see me?
Yes, good to go.
Oh, perfect. Perfect. Thank you. Thank you. We just left another computer behind. All right. Sorry. Our apologies for that. Colleagues, good afternoon. Good afternoon, Chair. Good afternoon, Dr. Sipo and Dr. George. Welcome. And let me just wrap up and say a few words as we charter the way forward. Firstly, in terms of the report back today at day 2 of proceedings, all I can say is first class work. And then thank you to all the presenters and to the chair and co-chair for your effort in putting together this package. What we're going to do is, in terms of yesterday's proceedings, day 1, today's proceedings, day 2, and tomorrow's proceedings, day 3, we're going to collect all the slides and we're going to publish the slides for you, both electronically and hard copy. And we'll get those publications to yourselves as a record of the proceedings. We will go one step further and we will write up the presentations as papers that will contribute towards what we term research productivity. And Minx Averbos, our editor at the South African Institute of Electrical Engineers, will package that and publish it in the What Now edition in January 2024. So we'll get the papers published. So we'll also have that recorded as contributions of day 2 and also day 1 and day 3 tomorrow. And we'll bring that forward. And that will give us a good collection of evidence in terms of the virtual symposium. We are certainly planning an international conference and exposition, most likely in the year 2024. That'll give us some time to put it together. And for the international conference and exposition, we'll be inviting papers from the global community to support us on this journey of how do we reset the thinking in terms of providing water security and sanitation for all, given the urgency around climate change and that of the impact of Industrial Revolution 4.0 and 5.0 on our operations. And to that end, as you note, we've got the South African Institute of Electrical Engineers as our partner. We'll increase the partnership amongst the various voluntary associations. We'll bring on board the South African Institute of Mechanical Engineers, the South African Institute of Civil Engineers, the South African Academy of Engineers, the Engineering Council of South Africa, the Consulting Engineers Association, and the South African Institute of Chartered Accountants to join us. And then we'll also reach out to our colleagues in the international community, IEEE of the USA, IET of the UK, and SIGRE of France. We'll bring them in on board to strengthen our workings and to assist us in terms of the journey forward. We will also reach out to our colleagues in the academic space, the universities, certainly all the universities in KwaZulu-Natal, where Mgeni Water is located, but definitely the universities across South Africa, and also the TVETs to come forward and join us as an academic partnership. Now, we're doing all this work under the leadership of the Faculty Industry Advisory Board, and we've got the Water Research Commission. Dr. Masibi is a standing member of the board itself. We will also reach out and invite Mgeni Water, the chair, the chief executive, to join us and to be part of the leadership that's going to help us to craft the strategy as we charter forward. An exciting partner that would be coming on board and is already with us at the Industry Advisory Board is that of Centec. Centec, the state-owned telecommunications company. And again, they have great aspirations and assignments, deep in progress in terms of the IR 4.0, IoT, virtual reality, artificial intelligence space. So with Centec coming on board, we'll be able to take a lot of the conceptual ideas to the next phase of development. And hopefully that's going to give us some deeper traction in terms of our way forward. So with strong leadership locally and internationally, we are going to look forward to what we term the whole portfolio of skills development. And thank you to EWCTA for your contribution today. And we look forward to you joining us on this continued journey in terms of skills development. Specifically, we're going to call upon the employees or the juniors amongst ourselves, the youth, to come forward and to come forward both with your registration of the various regulatory and voluntary associations. I think we've spoken about this before, but we want to give effort to this practice and this call, and also for you to come forward and take up your postgraduate opportunities to study further and to grow upon your bachelor's, your master's, your doctoral, and your postdoctoral efforts, and we'll assist you in that journey. And that is our core business as the university itself. And again, just not limiting it to ourselves as University of Johannesburg, but we'll spread it out to all our academic partners, and we'll bring forward the best skills and the best supervision staff to assist us and take us forward. So the employees would need to come forward and then give us a lot of their hands as such, and their time and commitment, and then we'll be able to then grow the foundation that will be required to bring forward this sort of next generation of solutions that we all talk about as in the conceptual ideas. So we're certainly clear about the way forward, the path forward, and I'm looking forward to an exciting time when we'll start to deliver some of these solutions. I had just this past weekend a lot of my colleagues from the People's Republic of China. They were passing through Johannesburg. They had come in for the conference in Cape Town last week. I think it was the African Utility or Energy Conference, and they were passing through. And we had the opportunity to meet and to chat about some of the work on hand. The People's Republic of China has just concluded their Congress, and I shared with them the good work that is taking place under the leadership of their team. And I remarked to them that their president, Xi Jinping, was awarded a honorary doctorate at the University of Johannesburg. We awarded him that honorary doctorate in 2018. We have a very, very good relationship with Tsinghua University and the academic institutions across. And I shared some of the ideas and thoughts that we've got on the table for water security as driven by 4IR. And they remarked that they would like to also join us on this journey as they have similar challenges back home, and they've already started to feel the impact of climate change the extremely hot conditions that they're experiencing, the drought-like conditions, and again, the toll that it's taking on their water supply. So we could have a very, very keen partner that will start to walk with us on this journey, as in mutual support between not just ourselves as in South Africa, but certainly ourselves as in Southern Africa, continental Africa, and then we look onto the bigger Asian continent as such. And I'm sure my colleagues in the sort of Americas and Europe would also have similar challenges, and we'll bring them also to come and join us on this journey forward. So it's certainly turning out to become a global assignment, one that is going to give us great value locally, but also globally, and we'll see best how we could then take forward the conversation, especially in terms of climate change and global warming. How can we also go knock on the doors of United Nations, the United Nations Paris agreements, etc., and find out how best they could also support us and assist us in terms of developing resilient solutions that will help mitigate and adapt to the future that awaits us. So we're certainly excited about this journey. We'll be meeting shortly as the Faculty Industry Advisory Board, reporting back to the board in terms of the virtual symposium that we've hosted for today and for yesterday and for tomorrow, and we'll bring that all to the board. We'll take further discussions, and then we'll give you further direction forward. All right, happy with that, Chair? Satisfied, Dr. Sipho? Happy? All right, Siyabonga, all of us very happy. All right, we'll hand over to Chair now. Chair, would you come in, Sipho?
Sipho, yeah. Sipho.
Me now.
Yeah.
Greetings again, Shalom, and all the colleagues all over the world where they are connecting us. I can't overemphasize the importance of this topic, as you have indicated, as we have seen in my indication that this kind of technology is actually what Umgeni Water should be becoming a leader with. It's our capacity to lead in the country, in the continent, and across some parts of the world, because you would hear even at the Water Week conference that countries in the developing world, be they in the South and in East Asia, are also looking for these technologies, with all these contradictions of having 1/3 of Pakistan in water while Europe is in drought of over 500 years. So these are contradictions we are living with, and it would be very, very important for us to really package our technologies. And you do this like this by trying out things. One of the people who taught me used to say, Sir Isaac Newton didn't just come up with his second law of motion. It was by trial and error, by watching and by looking and keeping the resilience on finding solutions. You will never, never stop if you are to innovate and get to solve the complex problems of the world. So I am very happy that Umgeni Water scientists have been here, led by our chairperson of the board, and we also did mention in the meeting with the chairpersons of the committees of the board that today will be this kind of groundbreaking think tank, so to say, for Umgeni Water. And we, I must say, now being an official, we also included this in the minister's monthly report that we were hosting this symposium as Umgeni Water, because we do report monthly to the DW as what we're doing. And we are grateful from the Water Research Commission, Dr. Msibi Ndlondlo, yes, Ndlondlo, to be really leading in this area, and we are going to be touching base with them as well. But from my side, on the executive side, and on behalf of all the chief officers and EXCO, we are delighted, Prof. and Dr. Tsibane, for the sterling work that we have done. And thank you so much, Chairperson, for coming with us all the way. We feel very, very secure when the Chairperson is in the house. you don't feel cold, you know. Yeah, you feel warm, and she has always been sterling in doing this leadership for us. Thank you so much, Prof. and Doc. Let me hand over back to you.
Yeah, thank you. Chair, that's your turn now. All I want to say that the meeting with Centec is going to be arranged because they've already funded Professor Petnado here to start up initiatives so that we can deal with the issues of masters and PhD students immediately on the technology solutions. Yeah. Can I hand over to you, Chairperson?
Thank you so much. I'll be very short. And my one, a total response to everything we have said as a team is let the games begin. Now, the let the games begin has been a popular starting slogan, which is actually an order that was given by the emperors in the Olympic, in the ancient Greek. And after sacrifices to the gods were completed to start Olympic Games. So it's a very big word, a very big moment. So when you say let the games begin, you mean everything that we hope for as a board and we hope for the water sector has been done, and we are giving a process a blessing which let start. So I'll end it there. Thank you so much.
Thank you. Thank you. Having all the you speaking, as well as the acting CE and all the colleagues from particular the Water Research Commission, Dr. Msibi, I'm very, very happy with the progress for today. The only gap that we are going to do, Kevin, you have challenged us on the non-revenue water. We are going to focus with Santec, as indicated, looking at solutions around the dams. How do we reduce evaporation around the dams? How do we also reduce the energy demand around the dams? Santec is prepared to look for that opportunity. We are going to discuss that going forward. Tomorrow, myself, Hlengiwe and Ru, we should be submitting the summary of the discussion today. Thank you. Back to Mintz, our host. Thank you very much. Well organized and also supportive in the process. Thank you very much for your energy and effort. And God bless you.
Thank you, Dr. Tsibane, and thank you, Ms. Matentwa, for hosting today's webinar. I want to just thank you, most importantly, our attendees for staying on. We are a little bit over time, but thank you for availing your time to listen to our virtual symposium. And then, of course, it wouldn't have been a success without our speakers, Dr. Mandla Masibi, Dr. Pat Naidu, Kwalisile Kunene, Mr. Kevin Mayer, Mr. Mpo Mokopele, and Prasanta Mandare, Gianna Riku, Tubela Gambu, and of course, our other lady from Umgeni Water. Let me just get her name here because she came on as attendee, Ms. Sachita Kolam. Thank you very much for joining us this afternoon. Please, you'll see the link to tomorrow's virtual symposium in the chat box. Click on that and register to attend. We'll be starting promptly at 10 o'clock tomorrow morning. Thank you all for your attendance. Have a good day further. Goodbye.
Goodbye.
Bye.
Thank you.
That's just...